Hello. Okay. Let's see.
Yes, sir.
Yeah. I think 32, including me. Should we wait for a couple of more minutes or we get started? I think I'll get started and I'll slowly introduce myself. And by the time I finish introducing myself, everyone will be here. Okay. Now let me share my screen first. I'm sending some messages to everyone not to text me while I'm in class. Um, Okay, can you guys say that, I mean, confirm that you can see my screen?
Yes,
Yeah,
yeah, we can.
yes, good.
Okay, okay. So we'll get started. First, let me introduce myself. Before that, what's your cohort number? Any idea?
12.
12, 1, 2.
Yes, one.
And you guys are, how many class you had before this?
At least 8 to 10 classes.
Okay, and may I, okay, with my daughter, may I have an idea of what is the class is all about, like in 8 classes, summarize briefly.
Primarily emerging technologies like RPA and digital twin, cybersecurity, and all that stuff.
Right. Okay. So
Blockchain.
anything covered on prompting LLM, how LLM functions in the overall level?
I think initially Dr. Shishadri had taken, before the formal class had started, he had taken one section on vibe coding and prompting. Nothing more than that. At least that's what I know.
Okay. Okay. Let's do this. So today's session is vibe coding, and in fact, it's not very big topic to cover in 2 hours, but there are some practices that we need to know how to do a vibe code, right? Mm, it's safe to say that everybody vibe codes nowadays. I do it. I do it day in and day out. But the problem is how to vibe code for legacy codes. You already have a legacy code, and you ask AI to write a code on top of that. How do you integrate this is a bigger challenge, and I will talk more about that, right? So to understand that part, how the class I have divided is, we need to have a very high level understanding. I'm not going into details because your actual classes will cover that on how LLM generally works. From there, go on talk about how prompting makes sense, what or other. Talk about different prompting techniques. How can use this different prompting techniques to harness this LLM. Okay, it's called harness engineering nowadays. We used to call this prompt engineering, and now there is a slight change in the focus, harness engineering. But I'm not going to touch anything on harness engineering. I will briefly tell you what it's all about, but we'll talk about prompting techniques, and then we'll do some vibe coding. Okay, that's the whole idea of today's class. So let me introduce myself. My name is Big One. Shonraj. B stands for Ballet Danish Rao. Um, I have a PhD, and my PhD is in computational neuroscience. Whenever I say neuroscience, people imagining that cutting open the skull, taking the brain tissue, putting under the microscope, and studying something. I did not do any of that. I did something called as computational neuroscience. What it means is, um, let's say, if one area of the brain gets activated, how is that affects the other area of the brain? Okay, and it is not much of neuroscience, although it's a neuroscience, but it's more of a mathematical modeling than cutting open the brain, right? So back into 2010, I started my PhD, and we used to call that time machine learning. So I used a machine learning technique called Bayes algorithm to study, given one area of the brain is activated, how it affects the other area of the brain. Okay. So that's all that was my PhD about. My undergraduate, I did something else in India, but I switched fields for my PhD, and I did on completely on machine learning project. Post that, I worked in UC Berkeley. I was in the Bay Area for 2 years, 1.5 years, close to 1.5 years. And I worked on some interesting machine learning projects. And then I came back to India. I joined academia as a professor, assistant professor, then promoted to associate professor, and went on to head on the department as well. So I worked in a university called Manipal University. Those who are from India will know that it's a very famous private university, where I worked on big data modeling on healthcare technology and things like that. Post COVID, some of my friends started a AI company in Singapore, so I joined them, and then we started working on our algorithm, which looks at the back portion of the eye and then say whether the person has diabetes or not. So we developed what do we call it as a CNN model to look at the pictures of the eye and then say whether they have diabetes or not. So that company was the startup was eventually bought by another company in India, which is eventually acquired by a pharma company, Sun Pharma company in India. So that was the product we worked on, and we extended the product to look at not just diabetes. We also worked on how we can look at the back portion of the eye and then tell whether the person has what is the risk of having that person having a heart disease or something like that. So we developed those algorithms, um, um, and we bought those algorithms into the market. And in fact, one of our algorithm is one of the first algorithm, AI algorithm, to get approved in India by regulatory bodies. We have submitted our algorithm now for FDA. It is under review. So that's the journey I had, and then post we handed over our company to Sun Pharma. All of us exited the company because our work is done. That's a pharma company. Our work is done, and now I work in a company called Insight Verge, where our company mainly focus on training and giving advisory solutions to big enterprises. So I have been involved in training for past 2 years now, for big corporates here in India, big GCCs in India. So that's what I'm doing. I have given my LinkedIn profile as well, linked as well. If you are interested, I will share the slides at the end of the class. If you are interested, you can go back and look at them more. So that's briefly about me. And I will not talk about myself any time after this. But if you have any questions that you want to ask me, you can shoot me now.
I want to ask.
Sir, your project sounds super interesting because those changes are very micro. When somebody has a diabetes and the retina get changes,
Yeah.
developing an algorithm and detecting if the person is having the diabetes or not is super interesting.
Yeah. That that was a very interesting topic because back in 2017, Google has published this paper. Till that, we were working on what we call it as a classic machine learning model. But that changed the topic, okay? And one of the big data for them, so they need a very huge data set to develop these models. And some of the data came from India. It's a very famous eye hospital called Aravind Eye Hospital, and they gave the data for that. And they have developed this model, and then they published it as well, open source. Um, what we did was we took that base model and we fine-tuned it and then made it available for the customers. Some of the models, in fact, some of the earlier models of ours are already in Europe. It's been in more than 15 countries worldwide. In US, it's a bit difficult because of the FDA challenges and things like that. So it's been 2 years, and there is a lot of back and forth reviews coming out from that. But that's the model. But later on, we worked on something much more interesting because back portion of the eye has this small blood vessels. Okay, they call it as microcapillaries. And in fact, the heart, human heart, is supplied by these small blood vessels. So if there is any lipid deposits in these blood vessels, in the small blood vessels, this will lead to what we call it as heart failure. Okay, in medical terms, it's called myocardial infarct. Okay, so these lipid deposits you can actually see not just only in the heart but all over the body, provided if you can image the small microcapillaries. Back portion of the eye provides the perfect place where we can image the back portion of the eye using micro. You can see this vessels, blood vessels, and human eye cannot see any in that. Like human, if you inspect very closely, these are very tiny blood vessels, very difficult to find lipid layers in it. But the CNN model can actually differentiate this. And so we built a CNN model, and we gave a score based upon the CNN model output on how much is the person at risk of having a myocardial infarct. And guess what? And we compared this AI outcome score versus a cardiologist. Usually they do something called pooled cohort efficient scores. And there is a very nice correlations between these two. And again, there are some academic papers on it. So we developed this huge data set we collected for. We've been collected that from 2022, just after the COVID. And then around 2024, 2025, we finalized the model, and then now it has been submitted for the regulatory. So that once that model comes out, if a person doesn't have to do a CT scan to identify whether the heart has, or an angiography to identify whether the person has any blockage in the heart. We can just take a picture of the eye and then say whether the person has, how much is the lipid deposit that's happening all over the body. So that's the novelty of that project, and it is a huge project we worked on, huge data set. And unfortunately, the copyrights have been now been transferred to another pharma company. They have taken over, but yes, so that's the model that we worked on. Okay, so if there is no more questions, and I will move on to today's class. Just one thing, I have a very typical Indian accent. It's very difficult for me to change my accent. If any of you have difficulty in understanding my accent, please let me know. I will slow it down. That's all I can do. I have a tendency to speak very fast. If I do speak very fast, please let me know. I can slow it down. Okay, and I keep this in my mind whenever I take a class. I slow down purposefully, but sometimes I get carried away and then I tend to speak very fast. So if that happens, please let me know. And also, during the class, if you have any burning questions, please stop, ask the question straight away, or you can put it in the chat. I will not look at your chat immediately, but periodically, every 15 minutes once, I'll stop and then I'll look at the chat box. Okay, right. Now, today's class, vibe coding. Vibe coding, this particular term, vibe coding, is actually is being tweeted by this guy called Andrew Karpathy. He's one of the guys behind Tesla, and he also worked in OpenAI formerly. Now he has a YouTube channel through which his majority of the income comes from. Fantastic YouTube channel. I strongly suggest everyone must go and look at his YouTube channel. This guy tweeted back in a year ago, 2025 February, and he just said that I don't code anymore. I do vibe code. That's it. Okay, and that one tweet that he put in has become it's become a huge viral thing. And now there is a Wikipedia page exists for vibe coding. Okay, so vibe coding means you let AI to do the codes for you. Okay, although this particular terminology, vibe coding, came into picture after this guy tweeted it, um, there are businesses built around this. Okay, for example, I don't know how many of you are coming from developer background. How many of you know this cursor ID? So this cursor is an IDE there. They have already been implemented for the LLMs to write generic codes for them, and they have already made businesses out of it. Not just them, all these companies where some or the other, some way or the other, had made businesses out of vibe coding, even before this term vibe coding comes into the existence, right? So, although this is a very fun tweet that he put in, there are businesses which were built around these words, and now there are companies who make businesses out of this, right? Okay. Now, to understand this vibe coding, uh, I have been training software guys for past 2 years, right? I have gone to very big corporates, people who have been writing codes for 10, 15 years, and now they have this GitHub Copilot integrated in their VS Code. And there is a top-down pressure coming to these guys saying that, hey, you guys have an AI with you. What takes you so long to write the code? And believe me, many people have actually given up the vibe code, because what happens is this: first you give a prompt to this LLM. LLM writes and writes code. It looks like a magic. It works fine in a first go without any errors. All looks great. But the problem is, the moment these AI generated codes, now you have to integrate with human written codes, which has been in there for past 15, 20 years, right? There is a company which I went recently who deal with payrolls, and they have close to 150 products in them with them. And now all this 150 products has been tested multiple times, written by humans at different stages of development. Now suddenly they're asking them to switch to AI. Now you have a human written code, which is known to have messy, not so properly commented, variables names are not properly written, and suddenly you have an AI written code which looks fantastic. Variable names are perfect, commands are written, and now you are trying to integrate these two, and it completely breaks down. Okay, so it gets very quickly, it gets super messy. Okay, so what we need to be there is we need to be very mindful on how this LLM works, on how this LLM understands our codes, and how the LLM writes the codes for us. So if you are mindful about that particular part, then you can easily master it. Okay, so it's a complete roller coaster ride, and believe me, I have been trying to do this for past 2 years with many people at not exactly the vibe coding, but I've been teaching them how to integrate their AI written codes with existing codes. How can we write the system integration test? How can we write test cases for AI written codes? And all these things, and multiple challenges we have faced it. But if you understand at base level what LLM does, it becomes much more easier for it to understand that how the codes have been written by the LLMs. Okay, so now let's get that first very high level understanding. I will not go in details because this is a very huge topic, and you will be dealing with this later in your subsequent class. Okay, and then we need to understand what prompt you need to give to get a better outcome. Okay, so we need to have a understanding about prompting technique. Then comes the vibe coding, right? So let's start with this question. Now I'm asking you to predict this. this is a glass. You might have seen this example, but if I ask this particular question, this is a class of orange dash. What is your predicted answer for this?
Juice.
Okay, fantastic. So juice is the first thing that comes out of it. But if I ask the same question, this is a slice of orange, or rather, this is a slice of orange pulp or something like that. Why did you say juice? Why you did not say this is a glass of orange slice? If I say this is a bowl of orange fruit,
So
orange.
juice is associated with the glass, right? Generally, we consume juices in the glass, right? And not in
Context.
cup. Yeah, context, right?
Okay, let me put this answers two things. One is juice is associated with the glass. So you get that there is a context. So you saw the glass, and because you paid, I use this word, because you paid attention to the glass, you predicted the next word to be juice. Correct? And you are associated, let me put that word another way. You have been trained, or you have been looked at orange juice, glass and orange juice. So your brain has been trained to see this. So you automatically predicted juice as the output. Correct? Similarly, um, so, okay, I did not have that example. So there is two things happens here. One, from your previous training data, or from your brain inputs that is coming from, you have seen juice many times, so you have predicted juice, and the juice comes from your attention to the bird of glass. If the same question, if I ask this slightly differently, this is a bowl of orange, then you might have said that this is a bowl of orange fruit or orange pulp or something like that, right? So you have paid attention to these words and predicted the next word. Correct. Now let's see how this machine understands which word to pay attention to and how it predicts the next word. Right? So we want this machine to understand these words and then predict the next word. But the problem with the machines, when I say machines, computers, the problem with the computers is it understands only numbers. It doesn't understand words. So we have to convert this, um, words into numbers. Correct. So the first step of this is called tokenization. Okay. Now you can convert. I hope this link works. So you can convert the numbers into binary. That's how traditionally algorithms works. For example, if I say this is a glass of orange, right? So I type this. That's the input that we gave to the computers. Now the computers can convert this into binary. For example, this can be 10001000. Okay. H can be, sorry, T can be that number, the word. H can be this number. I can be converted to this. Remember, this is 8-bit coding. Okay, so you have 8 digits: 1, 2, 3, 4, 5, 6, 7, 8, right? 8 digits. So you can convert this into number 1010101010001101, something like that. So you can convert this completely to binary. The problem with this is a couple of things. The moment you convert this into binary, it's just a set of numbers to the computer. It doesn't understand the context of it. So predicting the next word becomes really difficult. Second is, it doesn't know which binary number it has to pay attention to. Whether I should pay attention to this or I pay attention to this. Probably these 4 numbers here means glass. So I need to pay attention to the glass to predict the next word of juice. Correct? But converting this binary doesn't help us, doesn't make us to help that which words, which set of numbers that the computer has to pay attention to. So that's another problem. Third problem is, look at this. So it has 2 rows, and the third row has 3 columns. The moment I give one space, The space is also added as a binary. Okay, that also goes as an input. Okay, a comma, punctuations also added as another input. So these are another problems that with the binary, that punctuation space also takes up into the binary inputs. So it becomes really difficult. So what they do is they don't convert when we feed these words into a large language model. When I say LLM, I mean large language models. Okay, so when I feed this word to LLM, we don't feed it as a binary. Rather, we convert it into tokens. Now, this is a tokenizer. This is the first step of the LLM work. It's called tokenizing. So the tokenizer, this is from OpenAI platform. This is how it tokens for your GPT-5 model. Okay. So let's say this is a glass of orange. I type that. Now see how this is being chopped. This is chopped as one word. Is along with the space here is taken as the one token. I'm not saying word. I'm using the word token. A is taken as the token. Glass is taken as the token. Off is taken as the token. Orange is taken as the token. Okay. Okay. Great. You are taken the words. You just chopped it into single words. I won't call it a single word. I call this a token. Now these tokens, okay, are given some IDs. So they are converted into numbers. Okay. Now these tokens, we call this as the token ID. Okay. You take a text, the text is converted into tokens. Remember, the way each the model converts this tokens depends upon the model. Okay. For example, if I take the some word as anti-clockwise, right? Something like that. You see that anti till C is taken as one token. LOCOK is taken as one token. Y is taken as another token. Okay, this is how GPT-5 works. But if you go to the older algorithm, GPT-3 in the ChatGPT, they might have a slightly different way of tokenizing it. Okay. Question. So
yes.
Yeah.
So are there any, there must be some logic or something, right, in the back of things, the way it identifies certain words or whatever the characters as a token, right?
Yeah. So the logic goes, I mean, each one have a slightly different logic. Okay. The logic goes like this. You take a sentence. In this, if you convert it into atomic parts, this is one atomic part, E is one atomic part, A is one atomic part, glass is one atomic part, and then they went on like this, and then they created tokens. That's the initial thought. Then they came up with another problem. For example, contemporary, anti-clockwise, some words like this. Give me more examples like this. Clockwise and anti-clockwise, right? So anti-clockwise is a single word where if you consider clockwise as one token, but if you have another anti as another previous token to it, then the word meaning changes. Okay, so they went on to chop even further into the single word. So they took the single words and they even chopped it into smaller tokens, which makes much more sense from the training data.
It makes sense. Yeah.
So remember, I want you guys to remember one thing. Most of the times, you can imagine single word as a token, but that's not always true. Okay, because sometimes models might chop an individual word into half as a token, because that makes sense to it. Okay, that again, how does this token work? How this tokenization is being done? It is again looked at the large data. There's a math behind it. I will not go into the math part of it, but you convert this individual word into atomic steps, and each atomic steps is converted into tokens. Now these tokens are given some numbers to it. Those are called token ID. This is the first step of generating the next token. The idea is, if I give this set of tokens, this is a glass of orange. The LLM has to produce the next token. The next token is juice. It has to produce this word next token to me. That is the idea. So now I have even taken this word set of word, and then I converted into tokens, basically into some numbers. So that makes sense. Now let's what they have done. This is for the GPT-4 model, I guess, or GPT-3 model plus. I don't know what is the recent one they do, which is the proprietary, thing. But GPT 4.0 has converted this whole English words into lakh tokens. Okay, a lakh and 27 tokens, 277 tokens. And they said that this many tokens is enough for me to express the whole English language into it. So this may be a token, is may be a token, anti may be a token, clock may be a token, vice may be a token. Okay. So for example, Samwise. In this Samwise is a name. Clockwise is a different words. So they take this token, split it into small things, and then they express the whole English into this many number of tokens. This is true for GPT 4.0. I don't know what is there for GPT 5.0 plus, because that's a completely proprietary information, and they have not given this information out in the public. Okay, so now they have converted this into tokens. Second part is, this is the interesting part. Okay, I don't know how many of you know this, but this has been talked many times. What do you mean by vectorization of this token? Anyone have any idea?
I don't have an idea, but I mean, like from the name, apparently it's probably taking both weight and position into consideration. Maybe proximity to one another and all of that, or how far it is with a reference point. I mean, maybe.
Yeah. Not okay. Not really. The proximity and the reference point not comes yet. It comes in the next step. Okay. The first step is I converted into tokens, and I given some tokens, those numbers. And in this previous example, the token 287 means this. For a computer, 5,000 something means king, something like that. So we have converted this whole English words into some token. Okay. Still the yeah, go ahead.
Is this we are talking about, vectorization, a tokenizer is converting those IDs, which is generated by the first step, converting them into a matrix to store them.
Right. I am not yet into the matrix yet. But yeah, so you can consider vectors as a matrix as well. But in general, what do you mean by vector?
Is it? I guess
What?
that needs to be converted into some numbers. So
Correct.
for future mathematical purpose, I guess.
Some number attaching weights, giving directions.
Okay. Yeah, weights not yet, but we have read this scalars and vectors, correct? In our fifth standard, sixth standard, I mean, in our elementary schools and in our high schools. What do you mean by scalar, and what do you mean by vector?
For a vector, it has both value and direction, and that is where it helps.
Absolutely. So a vector means it has both value and a direction, correct? Whereas a scalar is just a quantity, how much it is. In vectors, I can express it in the quantity and the direction. Remember this. Now, let's take a word water. Tell me close words to this.
Sorry, could you repeat? Taking what?
Let's this word water. Or rather, let's take this example. It's a juice. This is a glass of orange juice. Closer words to juice.
Liquid.
Liquid. Fluid.
Pure.
Yeah, I did not hear what was the last one, but yeah, liquid,
Pure or mineral water.
pure, mineral, yeah, water. These are the closest words to juice. Correct? If I take juice, juice has all these attributes. Juice means it has to be liquid. Juice means it has to be watery. So all these are the attributes of the juice. Similarly, let me take another word, king. Tell me the attributes and the closest words to king.
You said N-I-N? N?
K-I-N-G, king, yeah.
Sorry, what was the word you mentioned? Closest to what?
King, K-I-N-G.
King, okay.
Oh, king. Okay.
Crown?
Monarch.
Prince, queen.
Queen,
Royal.
royal.
Queen.
How does it all set?
Samrat.
Blue blood.
Monarch.
Empire.
Emperor.
Caesar.
How does it all came to you? Suddenly, I'm asking two different words. One is juice. Suddenly, you're saying juice means water, pure, liquid. And then I'm asking another word, king. And you're saying monarch, crown, queen, power. How did you?
Prince.
Syntactic relationship, sir. Because of
Sorry?
the relationship. Because of the relationship.
How did you make this relationship?
Based on the attributes of the
By,
word.
We feed it
by,
in our
We have
mind,
been
like juice.
by
we have been
association.
taught we've been taught and
And recognizing the context difference between both the
Yeah,
words,
right.
probably.
Right.
I think that's more of a training and education. We know, these are the words associated with the words you mentioned. I mean, that's what we have been taught and learned.
Absolutely. Right. If we can answer this question, right, in neuroscience, perhaps we might get a Nobel Prize. In our brain, how it works. We really don't know, right? From our memory, right? So now imagine we have these words. We have this token. I'm going to use this word token. These tokens, we have this token ID. Now I can express this token as vector. Okay. Imagine water is in this direction vector. Okay. Now, if I go in this direction, I will find words, similar words to water, which is juice, pure, liquid, all the words, I can find similar words around that. I take another word, king, and I express that in vectors. Okay. I can express words like monarch, royal, queen, all those words I can express it in the vectors around that direction. Imagine you are going in two different directions. Okay. I will take the question. Just let me finish this point. Now, that's what Google did in 2017 or 18, somewhere around that, or 16, maybe. I might be wrong. This is what Google did with the word to word algorithm. They express these words into vectors. How did they do it? They looked at the whole Wikipedia and then they found the words which are close to each other, or rather, words which appear together and have similar meanings, and they express them as a vector. Now, the moment I express them into vectors, if I go along that direction, I can find words similar to that, or I can find attributes to this word. King attribute is royalness, crown, monarch, right? Queens, similarly, water's attribute is pure, liquid, juice, and all that. So I can find the attributes of this word if I go in those directions. I'll take question now. What's the question, Desmond?
Yeah, thank you. It's interesting. Also, I mean, like how you're kind of like pushing the question back to us, how we're able to associate one word with so many others. And yet, it says that vectorizing and tokenizer is arbitrary. So I wanted to find out, is it driven by neuroscience,
Yeah.
by how the brain works, and then what's that neuroscience called, and what part of the brain is driving these thought patterns? Thank you.
Um, okay. The neural networks, which is the main part of this large language model, is neuroscience driven. Okay, majority of the concepts were taken from the neuroscience. How to connect a couple of neurons, what happens, how do you model this neurons, all this were taken from the neuroscience. But the idea of putting this words into vectors is again driven from this philosophical idea. We never know, we don't know how we associate each word with other one. But mathematically, if you think about it, we can vectorize, we can think about that. If I go in this particular direction, I can associate those words with along attributes. Similarly, if I go in this particular direction, I can associate those words with this attributes. So how do I put words in direction? Vectors is the answer to it. So what they did was they took all this tokens and converted into vector. Okay.
Yeah. Yeah, very well. So sorry, just finally, just to so I'm not lost anywhere. So did you also say that the procedure or the process of tokenization is proprietary? So there's no documented process by which we tokenize words or something. Did you say that?
Yeah, I did say that. How do they tokenize? Whether they tokenize, they have their own algorithm to tokenize it. That is proprietary. But the process of tokenization is not proprietary. Meaning, I know how tokenization works. I can build my own tokenization algorithm. My own tokenization algorithm is proprietary of mine. Do I make sense?
Oh yeah, very well. I understand. Yeah. So you make your algorithm to be as smart, smarter than the other person's based on how you string it along or something like that, I guess.
Absolutely.
Thank you. Yeah, thank you.
Go ahead, man.
Just a bit of sidetrack. This vectorization, is this the basis for AI checker? Because when AI is checking for plagiarism, for example, or AI generated words, do they also use this vectorization to determine whether this essay has been AI generated?
Okay. There is a lot more math to it, but to some extent, it does use that. So now, the moment I convert these words into vectors, right? I can look at similar words, or rather, now you imagine one paragraph or one whole page. I can convert into vector. I have this vector, and I see how this vector is similar to something someone else has written. Okay. Now I have two vectors. Let's say I wrote the paragraph, and someone else has copied the paragraph. Okay. My paragraph will have some vector with some direction. And if I convert that person's paragraph, if he has copy pasted my paragraph, and that vector will also have a same direction. So if I do a dot product multiplication between these two, or if I multiply these two vectors, these two vectors will point to the same direction. Then I will say that, hey, these two vectors looks very similar. So perhaps one person has copied from the another person. So this is how the plagiarism checker works. Okay. In fact, now you think about this. You can convert whole songs into vectors. So in Netflix, if they want to find out a song similar to that, you don't specify the genre of the song. Okay. But the moment you play that particular song, the next song automatically comes up for you in Spotify, because it knows that along these vectors, these are the similar songs that this person might like. Okay, so vectorization is the way how your Spotify works, your Netflix algorithm works nowadays. Okay, yeah, so there you go, that's the answer to it. Now, the beauty of this vectorization is the moment you convert, so the numbers, now you have a token ID, right? Now, these token IDs are converted into vectors. Now, these vectors can be something like this: 1000011221100, something like that. Okay, it's binary form of various length. Okay, word to vec, put this into, let me see if this link works for me. I might be broken. Broken. See, word to vec took each token, put it into 364 vectors. Okay, ChatGPT 4.0, put them into 12,288 vectors. That means the word this is expressed as 1288 rows or columns of numbers. And the numbers means 100, 1100, 1100, something like that. Some binary number would be there. That number means this to the computer, but it doesn't mean anything to us. Okay, so I have taken a sentence, convert into tokens. Now those tokens are expressed as vectors. The beauty of this vectors is I can take a word like uncle, and then I can minus that uncle with man and add woman to it. Automatically the vector will give me the ant as the answer to it. So suddenly I can do some mathematical operations too. Okay, so convert uncle into vector, man into vector, woman into vector. So take uncle vector minus man plus woman will automatically give me the answer, something like aunt. Similarly, you take a king minus man plus woman will give me queen. If I take a doctor, minus woman, sorry, minus man plus woman, what is the answer?
Maybe nurse.
Doctor only.
Maybe
Female doctor.
It will be doctor only. It should be doctor. Maybe AI will convert it
Yeah,
into nurse.
female doctor.
it should be doctor. Should
Yeah.
be female doctor. But guess what? AI predicted that as a nurse. Okay. Anyhow, those are the bias that is inbuilt into our society. That is getting reflected in the AI. Some of the AI has been trying to make this less gender bias. But anyhow, now you can. The idea is this: you take the vector tokens, express them into vectors. Okay. So what happens is like I told you, take a word water. The water will have a different attributes. Rajeshwari, to answer your question in the chat, is in Netflix and Spotify use recommendations models? Yes, they were using recommendations models, but nowadays the vectorization is much more faster to it. So what they do is they convert these into vectors, and these vectors are now built on top of the recommendations model. Previously, they used to use something called one-hot encoding. I'm not going into the details, but one-hot encoding is something you express that into, again, numbers, but a slightly different way. But now they take these vectors. These vectors are now built on top of the recommendations. Okay, can you throw some light on embedding lookup? I am there. I'm coming there. I will explain what I mean by embedding. So tokens are converted into vectors. Now, if you take this word water, it has different attributes. The moment I put this into vector space, I can look at these attributes along that direction. So imagine that you are going in this, there is a 3 dimensions expressed here. One is the technique direction, one is the nature direction, another is the cosmos direction, right? Your cloud is more close to the cosmos direction, and it is again closer to your nature direction, but it is far away from the technique direction. Correct. Similarly, you take a robo. Robo is far away from your nature direction. It is much closer to your technique direction. So now suddenly I can put this words into this different vector spaces. Imagine your ChatGPT puts them into, we can imagine only three-dimensional vectors. ChatGPT puts them into 12,000 vector spaces, right? So 12,000 vector spaces has been put, and the words are expressed in those vector spaces. Gautam, yeah, go ahead. Question.
So, Professor, on an example of Google Ads. So, if we search for a particular word and then we start getting the ads related to that word. So, particularly what they're probably doing is that they're tracking that vector to identify a similar kind of words. And sometimes the ads could be completely unrelated, but to it can have some resemblance to the word. So, is that something an error for that vector towards which it is being suggested?
It's a oversimplification to think about that the Google words converts directly to the vectors and then finds similar vectors, right?
Okay.
It does that. That's the first step of it. But on top of that, they also build some recommendations models on top of it. Okay. But um, to answer your question, why it goes wrong, sometimes it may go wrong because it looks at not your individual behavior, it looks at your general search behavior. If the general search behavior is something like that, someone searched for a dog and then looked immediately after that some cat food, perhaps that person might have both a dog and a cat and might give it as a recommendation to you. We
Okay.
can't help with that. So those are the things that behavioral data driven, data driven recommendations that comes out to you.
Okay. Okay.
Tushar,
Just a
yeah.
question. I am not sure the right side image with the three axes, right? Cosmos, nature, and tech things.
Yeah.
Is it something like for each token we can have, or like why? Are there any? I think am I missing something?
Let's imagine I converted robo into token.
Okay.
Okay. Now the robo is converted into token. So let's imagine robo is a token, single token.
Right.
Now this token is expressed as a vector.
Okay. Correct,
now
correct.
robo token, correct? For simplification, let's only we have a three vectors, three-dimensional vectors: cosmos direction, technique direction, and nature direction. If I ask you to take this token, robo token,
Okay,
and
that way. Okay.
express them in vector, you would associate this towards the technique side.
Yeah, more.
In your nature
Compared.
side.
Okay, okay. So
see the guy astronaut.
correct,
He's
correct.
more close to the cosmos and technique than your
Right,
nature.
right. Right. So, okay, my question was basically the three axes that we have chosen or taken. Is it just hypothetically created, right? It's not like always the case. Okay, okay.
Similarly,
Yeah.
those ChatGPT, that 12,000 vectors, right? 1,288 vectors might mean something. Okay, one vector, one direction might mean royalty. One direction might mean purity. We don't know what the direction means. We shouldn't be even be trying to understand those directions. Okay, but somehow the computer learned from this big data and learned to express this into 12,288 dimensions. Now reason models are not 12,000 dimensions, they are even bigger dimensions. Okay, this is I'm talking about 4.0 model from the GPT.
So, Professor, here is the question. So, let's say, in vectorization, let's say we are using the word orange, right? So, it gives some vector value. Then, let's say we are using the other word called apple, or it could be banana.
Yep.
It gives similar value or close value what we got for orange. How it happens, how it detects that, it is the fruit we are talking about. Or for that matter, water and juice example, right? How it happens.
Yeah. Good question. But in general, if I say these two words, orange and apple, would you put these two words together or you put separate these together separately in your mind?
No, these are the separate words.
Two are separate words, but if I ask you to put it in a space, okay, Would you put this orange and apple in a same space or a different space?
Same space, because we
Same
know.
space, right?
Yeah.
I give two sentences now. This is a glass of orange juice. It's the first sentence. Second sentence is, my Apple phone is awesome. Okay.
Two different spaces.
What did you change? Now you said that you would put these two Apple and
Context.
orange.
Yeah,
Context.
context. Because next time Apple is associated with the phone, not as a fruit.
Right. So that is the next step that we have to do. I will explain that part. Yeah. Harsh, you have a question.
Yeah. So, Professor, like as you mentioned, like GPT 4.0 is like having 12,288 dimension. But
Correct.
behind the scene, we also have been hearing like these models are trained on the billion parameters. So
Right.
those parameters and these dimensions, are they same or different?
No, no. I will come to that part. Sorry.
Okay.
So I will come to that part.
Okay.
I have small question to the next slide,
Yeah.
So it is possible by this way we can have n number of this 3D space, right?
Yeah. N
Like
number
for
of
each,
dimensions. Yeah.
okay, n number of dimensions, right? Like I means okay, excellent. Yeah.
That's where I'm saying it
Okay.
is 2,277, whatever the crazy number of dimensions. Yeah.
But if it takes all this much to understand two words and compare between the two of them, what it's gonna take to understand a full page or a book or a paragraph, the computational power needed to do all of that is massive.
Yes. Yes. It is massive. That's why the data centers exist. That's why whenever you want to predict the next token, let's say you take a Claude 3 trillion model, 3 trillion matrix multiplication happens every time it predicts the next word. So it's a computation is very intense.
So
Model.
can I, with respect to tokens, I've read somewhere that if you are in a particular session and you're having let's say discussion or a session with ChatGPT or any other LLM model, as you go down into that discussion and the time, the length of that discussion increases, the response of LLM models kind of starts changing, the behavior starts changing. It is less accurate, it hallucinates more. So what is the reason for that? Because ultimately, if it's all token and vectorization, then and it's compute, then the response should be accurate, or it should be as when I started the new session.
Because hold this question, okay? It's called context engineering, okay?
Okay.
I will answer this to these questions. What is mean by parameters, billion parameters? How does it get better and better? I will try to answer these questions. If not, please do ask me at another half an hour's time. Okay. So two things are clear. We converted into tokens. Those tokens were now expressed as vectors. Okay. Now, the moment I put it in vectors, it is going to cluster automatically. Correct. So look at man, woman, all close together. This is a very small model. We used it to plot it. It is perhaps but taken it from the internet. Need not to be accurate, but you can see that international leave, all these are similar words tend to cluster together. So we can go in that directions and then find similar words also. Right. Now this is the question you have been asking. Context length is something that we need to understand it. Whenever should I explain this here or should I explain this later is what I'm thinking. Whenever I ask you to predict something, this is the class of orange dash. This is one token, is one token, orange is a one token, juice is one token. Sorry, how many tokens I added? This is a class of orange, 6 tokens, right? So we have 6 tokens and we need to predict the next 2 token, which is the 7th token. What usually ChatGPT does is it doesn't predict one token at a time. So it has the context length is 128K. This is again 4.2 model. 128K is the total token length of a of a context length of a model. Okay. In fact, your Gork and Claude now have more than a million with the context length. So the first 6 tokens of this is a glass of orange. The next token is juice. After that, it will just pad with zeros and then gives us an output. Then you ask the next question, where did I place my oranges? What it does is it takes the previous tokens, 7 tokens, and then these tokens, where did I place my oranges as well as the token. And all these tokens are sent to the LLM models to predict the next token. Okay, that would produce one more token. Then you ask another question. The previous thing, all the previous things are sent together and then asked to predict the next token. So now what happens is, as you start speaking to the model, the context gets clearer and clearer to the model. Because now it is looking all the previous tokens and to produce the next token. Okay, so your response gets better and better as you start speaking to the model closer and closer. However, if your tokens are out of context, if you have used million tokens, if you are exhausted with million tokens, what happens is the next time you ask, it drops the first few tokens and then takes the last and then takes this token. So for example, you have a million tokens. Now you are inputted another 20 tokens. It drops first 20 tokens. Okay, so that's how you lose the context. This happens a lot in your vibe coding. Because in vibe coding, you ask a question, hey, can you write a code for me? That is 5 tokens something. That is your input tokens. What it gives out is probably 100 lines of code. That 100 lines of code might have 100 tokens or 200 tokens. Okay, so in vibe coding, it's very quickly your context will get explored, and that's one of the major problems in the vibe coding. If you guys don't understand what I'm talking now, just hold for a second and I will revisit this concept one more time and see whether that makes it clear. Oh, okay. And I'm just looking at the chat now. This is only for English language, I assume. I assume this will be similar for other languages. Yes, it is similar for other languages as well. The prediction is non-deterministic and is probabilistic. You are absolutely bang on right. It is probabilistic in nature. Okay. Because, sorry, I have a question.
Yeah. So I understand now what you're saying in terms of losing the context, because as you go into the discussion in chat, it kind of replaces the initial set of tokens and it replaces with the new set of tokens. So maybe that's one reason that the answers start becoming a little wayward in terms of what it's talking about. Now there's also a problem of they're reaching a limit, saying that okay, this session cannot go on any longer, and you start with a new session, and then you have to start with a new context because it doesn't remember that.
Yep.
So why and how does that happen?
Because you completely used the chat limit. You used that context length. 1 million, let's say, is the context length. You are already used it. So it cannot take any more tokens. Now, what ChatGPT does, or rather what Claude nowadays does, it doesn't drop the first few tokens. It asks you to start a new session. What you can do is, you can ask Claude to give a hand over the session. Okay, so let's say if your session gets slower and slower, and then it is stop responding, and it says that your session has reached its limit. Just next time try this. Please create me a handover.md file for me to just hand over.
I tried asking it to summarize this so that I can start a new session so that it can get a context. Maybe I'll try that handover.md stuff if you talk.
Yeah. So
handover.md file, right? .md, Mike Delta.
Mark date, yeah. MD stands for markdown file, yeah.
I've also heard that using an MD file is a much better way of explaining, of uploading the data, the files, instead of uploading Word or PDF files, because PDF and Word take more tokens. Is that true?
Not really. PDF and Word are proprietary related. Okay, couple of things. PDF, it's much easier to write it in. I don't know. Okay, Word is different genre. Okay, forget about that. It's a Microsoft proprietary. PDF, yeah, you can do that. But developers are much more easier. It's much easier to write simple language text in Markdown file. And that's probably the reason. Not just that, nowadays agents, when we create agents, there is something called skills of the agent. We define that in default. So it becomes easier. Yeah. It's just the developer, I guess. Yeah. Someone else raised the hand. I see Vikas plus one. So who's that plus one? I have no idea.
Yeah, it's Desmond. It's Desmond.
Yeah.
So
Yeah.
so I just wanted us to like have an alignment on vectorizing tokens with the terms arbitrary, non-deterministic, and probabilistic. So are they all aligned?
How does it all align? Please give me some
Exactly.
time. Please give me some time to complete this slide. Let me see
Okay.
how that. Yeah. Yeah. So
because we've used the three of them, so I mean like
yeah.
So I know that probabilistic is probably non-deterministic, but it's surely not arbitrary,
Yeah. It is not arbitrary. It is probabilistic is the answer. Anyhow, so we have taken the tokens and we are predicting the next token. So we take this word, this is a glass of orange. We paid attention to the glass and then we might predict the next word as the juice. The clouds are in the sky, not data centers, right? So the clouds, we know that we now associate in the, perhaps made us to say that it is in the sky, right? This is very interesting. Let me look at this word. I met a French girl in a conference. We liked each other a lot. Her folks are conservative. I need to convince them. Here I'm booking my tickets to
Paris.
How does we say Paris when there is Paris did not even come into this context, right? How does you say that? Because it's France, and then immediately we said it is Paris, right? So we paid attention to these words, French, correct? French girl. Perhaps that made us booking tickets. The book tickets, French. I am in a conference that all made us to say that Paris is the answer. Okay, so couple of things are important. The order of the wordings is important. Not just the order. I need to know, pay the attention to the particular words as well. So what it does is, I looked at these important words and I need to pay attention to these important words for me to predict the next word. In this case, it's a n minus 1 word, n minus 2 word, n minus 2 word, and n minus 4 words, and things like that. So mathematically, you can express this using sentence notation.
So why interestingly, I said Paris here. I mean, like it's a bit different for me because her parents are conservative, and then I need to convince them.
Yes.
So it's because of she's French, yes, but her parents are conservative, and then I need to convince them, and that is why I'm going to Paris.
Yeah. So there you go. So you obviously, I mean, this is an example thing I'm saying, but you did pay to few words, and that made you to predict the next word. Correct. So this is the main part that has been cracked in 2017 paper, and the paper title is called "Attention is All You Needed." Okay, so you take a word, convert into tokens. Those tokens are converted into vectors. Now the vectors has to go into something called as a positional encoding. I did not explain that part. I missed the slide. You need to say positional encoding, meaning this is the first sentence, is the second word in the sentence, A is the third word in the sentence, class is the fourth word in the sentence. So you add positional encoding to it. Then this positional encoding needs to go into the attention blocks. Okay, so this needs to go into the whole words needs to go into the attention blocks. Now what happens is these vectors, first I have a simple token ID, then I convert it into vectors. Now this vector is multiplied with the positional encoder that goes into the vector. That vector becomes positional encoder. Now that vector is sent into something called as the attention blocks. These attention blocks are developed on a big data where it looked at very huge data set and then knows which words it has to pay attention to predict the next word. Okay. Now these attention blocks are nothing but matrix multiplication blocks where these vectors are passed into. The blocks will convert them into give weightage to these words. In this case, it will give more weightage to these words. Okay. For example, this vector. This is a vector, right? That vector is multiplied with your positional encoder. Then again you multiply with the attentional encoder. Attention blocks will multiply that. So those attention blocks will give less weightage to this. For this, it will give weightage something like 0.1% weightage. For glass, it will give 0.9 weightage. Orange, again, it will give 0.9 as the weightage. So you multiply these vectors with these weights. And then what comes out is a multiplied vector, a vector which is both positional encoded and then had attention, went through the attention block. What comes out is a complete vector, a set of numbers. That numbers is called the embedding. Somebody asked a question, what is embedding?
What is endpoint? Sorry, I was not able to understand what is the endpoint, n-2, n-2. What is the context there?
See, you all agree that I need to pay attention to certain words.
Yeah.
Now I have taken the numbers, which is token ID, converted to vectors, multiplied these vectors with the positional encoders. Then I send this into this huge network, a black box of transformers, of attention blocks. These are called attention blocks. You send it into this attention blocks. These attention blocks are developed on a large data. So they know for which word I need to give more weightage to, which word I need to give less weightage to. So you send this vector into this attention block. The attention blocks will give individual words weightage. What comes out is a vector. Those vectors which came out of the attention block is both positionally encoded and also context rich, meaning it knows which word to pay attention to. Correct? So that is called an embedding. So the numbers, the best set of vectors which comes out is called embedding. It's a technical term, people use it. And there are models called embedding models, which will just basically take a set of words and convert it into embedding.
So this whole process is referred as embedding stuff, right?
Correct. This whole thing is called an embedding. So now what it comes out is, this is a glass of orange with a single length of vector, and that vector being, this is a glass of orange to a computer. And it knows that it has to pay attention to the glass and orange. That is an embedding outcome, what it comes out. Okay. So yeah, go ahead.
Does this process have a neural representation? Or I mean, like, is it just out of the blue?
Not yet. Neural network comes in after.
No, I mean like natural neural, that's a human neural representation. That's number one. And then number two, does it keep retraining itself constantly as it does this?
Not constantly. Data will be collected. Data will be collected and then periodically it gets updated. So the 5.1 model, 5.2 model, 5.3 model gets updated. It doesn't get updated every, like, it doesn't get updated every time the response, and then it just doesn't get intended. That's it.
So how does it score itself to know that okay, that the precision of this particular chain was right, so which is stored, that's now used to update the later models? I mean, I'm just wondering.
Oh, okay. So when you ask a question in let's say everyone is ChatGPT, right? Or other Claude also, you type something, it gives two responses, and it asks you which responses you like it. So you give a thumbs up to it. It's called human reinforced learning. So it uses that to learn that which feedback is better. If you have used ChatGPT back in 2022, 2023, this would have you would have seen that it will give two response and it will ask you to tell you which response you like it. And based on that, they updated those models.
Oh, okay. So is this also related to the RSI, recursive self-improvement?
What is RSI? Sorry.
This procedure, is it what is scaled to RSI or what will be scaled to recursive self-improvement of the models themselves?
Okay, so this is the final step of an LLM. It is called human RHLF, or rather something reinforcement. It's human in the loop. Okay, RHLF, reinforcement learning with human in the loop feedback. Okay, this is the final step of LLM fine tuning, where LLM produce some tokens. We don't know whether those tokens human liked it or not. So you ask a human to give a feedback. Based upon the feedback, it takes those feedback and keeps it in the backend. For the next model that they are developing, they will fine tune the attention blocks and the weights and bias based on them. Did I answer your question?
Yes, it answered the last part of my question. But what I was asking is also because, there's also the process which is in development, which is a recursive self-improvement, where the AI is able to train itself to be able to reproduce its a replication for itself, is able to reproduce itself without human intervention, which is recursive self-improvement. So I wanted to know if it's the same process that's been applied for recursive self-improvement.
No. You are talking about something completely different, something called as the distillation models. It's way too forward to talk about it. For now, I don't want to confuse you too much. But there is a way that it can be done. Let's not talk about that now. I might confuse you too much with that information. Okay. But
Professor,
thank you.
Professor, for the attention block, as you mentioned, like that this will have less weightage and orange will have more weightage. So for any new sentence coming into the model, the word this will have the same weightage in the attention block, or like that weightage will also change from sentence to sentence?
That word, as you keep chatting with the model, right? So, like I told you, this is a glass of orange juice is the first tokens that it produces. Juice is the token it produces. This is the glass of orange is the input tokens. Juice is the output token it produced. Then in the next question you ask, where did I place my juice, right? So now your input token is both. This is the glass of orange juice, what it came out. Also your words, both is sent as the input token. Every time this goes as the input tokens, every time this is being tokenized, every time this has been vectorized, every time it has been sent to the attention block. So each time it's done, the weights to this attention blocks, weights that is being changed, it can change slightly. It can change slightly.
Got it. Thank you.
Okay. So every time it goes into this attention blocks and comes out as a embedding model. Embedding comes out as an embedding. Okay. So you take this set of words. These set of words have different meanings. For example, I want a stylish car. Okay. Please produce an image of a stylish car. This is also car. This is also car. But it knows that stylish is the word that I need to pay attention to produce this image car. Okay. So this thing goes into the attention blocks, and then from the attention block it goes into what you call it as the neural networks to produce the next word. Is called transformer architecture. Okay, so it takes the set of words, sends it into this attention block. What comes out is this context rich vectors. These are called embeddings, context rich embeddings. Now these embeddings are now sent into what you call it is this black box of neural network to produce the next word. Okay, this is a oversimplification of a transformer architecture. But this is how the basic transformer architecture works. You take a words, convert it into vectors, send it into attention block. What comes out is a context-rich words, numbers. These context-rich numbers are sent into this neural networks to produce the next number, next tokens. That's how the whole transformer architecture works, right? So the transformer, rather the neural networks looks something like this. I will not go into details, but here is where the weights are there. Okay, each one each circle you can think as a neuron. It will take some input, it will do some matrix multiplication, and then sends it to the next layer. Again, it will take those. It will have some numbers. These are called weights and bias, and it gets multiplied and then sends to the next layer, and then gets some weights and bias, gets to the next layer, gets to the next layer until it predicts the next token. Okay, here is where we have this weights and biases, right? This is called the parameter. When I say 3 trillion parameters, this is what I mean. Okay, so in that neural network block. So in the transformer, so I have first half, which is vectorization and attention block. And the second half is the neural network block. That neural network block will have weights and bias. That is where I say that it is a total parameter. So when I say 3 trillion model, that means it goes through this many number of 3 trillion number of matrix multiplication to give the next one. Did I answer the question? Someone asked the question, what do you mean by 3 trillion parameters? That's what it means.
Yes. Thank you.
Okay. So your chat GPT 3 is 175 billion parameters, whereas chat GPT 5 is 1.8 trillion. So billion and trillion, it's a huge difference. That many number of matrix multiplication that it goes through every time you ask a question. Every time it produces a token, that many number of matrix multiplication happens. So it takes a token's ID, converts the token's ID into embeddings. The embeddings are then converted into your positional encoders. Then it goes to your attentions. Then it goes to your weight blocks. And then it goes to your feed-forward networks. These are the attention blocks that goes into. And then what comes out is the final number. And the final number again means something. Those are token IDs. Those token IDs are again converted back into words to give us the next token. This many number of matrix multiplication happens every time you ask the question. This is a glass of orange, but producing that one word juice, this many number of matrix multiplication happens. And remember, always LLM does produce one token at a time. And moment it produces one token, the whole tokens are sent back to produce the next word. For example, I asked this Berlin is the capital, is the question I asked, or something sentence I sent in. It sends into the tokenization. These are converted into tokens. These tokens are now converted into this large language models, which have both attention blocks and the feed-forward networks, neural networks. What produces is it produces multiple tokens with some probabilities. The tokens which has the max probability is taken as the output. Okay, and that is produced as the next token. Okay, in this case, the cat sat on the is the question I asked. It produced multiple tokens as the output. Mat, cat, fence, window. The one which has the highest probability is taken as the output and given as the output. So there you go. So someone asked, is this probabilistic in nature? Yes, it is probabilistic in nature. It is not deterministic. At the same time, it is not random also. So it's probabilistic in nature and looks at it produce multiple tokens. Whichever token has the highest probability is given as the output for your sentence. Okay. Now that token, whichever is given as the output, is again sent back in to this LLM along with the previous tokens to produce the next word token. So your LLM produces one token at a time. Every time it produces one token, the whole thing along with the previous input is gone in again to produce the next token. The whole thing goes in to produce the next token. The whole thing goes in to produce the next token. So it is an iterative process, and every time it produces this token, it takes this many number of matrix multiplication to give out the answer. Any questions so far?
Yeah. So So my question really is, are there ways that you interact or that you send in prompts that makes the AI more effective or that increases the probability that the response you would get could be superior to what somebody else who had sent in a prompt in another way would get? And what are those? Thank you.
Yeah, good question. That's where I'm leading to actually. Um, um, let I will explain that. I will see if I can. If I don't answer that in another half an hour, please do ask me that question again. Okay. Now, let me show one quick example to this. Okay, this is a simple transformer block that has been put forward by someone, open source. Let's say I ask this question: data visualization empowers users to, is the question I ask, and it needs to produce the next token. What would be the next token you guys would say? Data visualization empowers users to
Take decision.
take decision. Okay, so take is your next token.
Yeah.
It will be a verb.
It can be a verb, right? To see, to visualize, to create. I don't know. So all these are right answers, right? So I send this set of words to this embedding model. So basically what the embedding model does is you take the data, you convert them into tokens. These tokens, you see that data is one token, visualization is one token, EM is taken as another token, power is taken as one token. These are given token IDs. These token IDs are now given the positional encodings. You see that this is position number 0, this is position number 1, this is position number 2. So it gives the positional embeddings. Then it goes into your transform attention blocks. Okay, it goes into your attention blocks. And what comes out of this attention block is the set of numbers. This is a, what you call it as the embedding. Okay. Now these attention blocks are again sent to, where is that? Oops. Oops. Where did that go? How do I minimize it? Okay, I'm sorry about that. Go back one sentence. Oops. Go forward. Okay. Yes, sorry. I have to click here. So that attention block goes into what you call it as a multi-layer perceptron. This is where the actual neural network is, and it produces a set of tokens as the output. So it produces visualize as a token, create as a token, see as a token, make as a token, see as a token. All these tokens are produced as an output. The one which has the maximum probability is taken as the output and given you as the output for you. So in this case, data visualization empowers users to visualize is what it is generated by this simple transformer block that has been someone has been built for us.
So these token IDs you mentioned, these are predefined in the LLM models. For example,
each
like
LLM model will have their own tokenization algorithm. Those are predefined. So it goes via that algorithm, and then the algorithm converts them into tokens. That's it. Okay. Now the problem is, yes, machines can make mistakes. It can make errors. It can be biased. For example, take doctor minus man plus woman. It may give nurse as the example, because these biases are inbuilt in our cultures also. So that's another problem. And there are cases, corner cases where can be completely thrown out and it will hallucinate. Okay, so this is the problem with the LLM models. Now, let me ask you questions from your understanding of your LLM models. We now know that LLMs now can understand a language. LLMs can understand the context of the words that we are being giving, or context of the sentences that we are being giving. Is LLMs can make codes now? Because code is a completely different thing. I ask you to fill in the blank. You guys can easily fill in the blanks. But the same thing, if I ask, I don't know how many of you are coders, but if I ask you to write the codes for you, Are you good in doing that? The answer is
What I know,
no.
LLM can certainly generate codes. I mean, I'm using it. I use Copilot. I use, Claude to generate codes.
Yeah, so I mean, Codex from ChatGPT and Claude on has its own coding, and I think so. Yeah, I mean, LLM models can code definitely. Is that the question, or do you have some other? You're asking
I
something.
Yeah, I'm asking that. Priya, you have raised your question hand, so please ask. Yeah.
Okay. For me, I'd say I started using it only 2 months before. And one of the challenges means my team uses, but I started having the hands on. And then what I realize is for an already existing code which has context and information and data and everything, I see the code that is generated is limited and contextual and presentable and usable. But
I
while
love it.
doing
Yeah.
this, that's
Yeah.
the gist. But then when I wanted to try something new, that is, I wanted to create a skeleton. Like that's how we use for the code, create a skeleton and add on so that you get debugging, you
Yeah.
will be able to handle. But then it's gone haywire. I see for one small question that I asked, it has created me 25 files and I have no idea from X to Y where is it going, why is it using so many. And I try to debug,
Absolutely.
try to use it, and then tomorrow somebody comes back and asks me that this is not working in my code, can you fix it? I cannot do it, and I realized
Yeah.
it's going to be an utter waste of time to go with this procedure. Either I create some skeleton and then tell it add something to it, or I will have to give 120 page or 10 page of what is a requirement and tell that do this, do this, do this, and then create it. So I am actually presently in that state where I was supposed to present, but I can't give a presentation because it's messy. It's totally
Absolutely.
messy. It's not debuggable, and I am finding it as a challenge as of now. That's my means a very current condition.
Yeah. Yeah. Priya, you're not the only one to face this. Millions of people who are doing the same facing the same problem. Okay. Um, to answer my question, LLMs are very, very, very bad in writing codes. It can understand natural language. It is very bad in writing codes. It is very bad in mathematics. Okay. If I ask an LLM what is 2 plus 2, it will give me the answer 4. Not by doing mathematics, but it has somewhere seen the data 2 plus 2 means 4 in its training data. That's why it gives the answer as 4. You ask an LLM some complicated question, math question, it will break. Similarly, LLMs are very bad in looking at the code, understanding the code, and writing the code back to us. Okay. Whereas you can use fine tune an LLM. You take an LLM, fine tune it to write a particular program in language for you. So, for example, you take an LLM and then fine tune it to write only Python codes. You take an LLM, fine tune it only to write JavaScripts. That is possible. But again, even after fine tuning, they are poor in producing codes for us. Okay. So the reason, if you see a LLM generated code versus a human code, you would see a complete difference. I will show some couple of codes in a minute. That's one. Second is it's verbose, meaning it just throws out a lot of tokens as output. You can minimize this token output by doing a proper prompting. That's what Priya said, right? You can say that, hey, don't give me this, just give me this. By giving a proper prompting, you can make the LLMs to respond to you in a slightly better way. Okay. In fact, if you have a proper prompting technique, you can make it LLM to respond to you in a much better way. Okay. So writing a good prompt actually matters. and making on this prompt, you can make the words too. You can write much better codes. Okay, remember, LLM don't understand context early. They predict next word. All they do is they predict next word or predict the next token. Okay, and they don't do reasoning like human, right? It understands the sentence and it predicts the next token. That's all. That's all they do. So your quality of your prediction heavily based upon your prompting. So if you give a clear instruction, clear prompting, then LLMs can make fewer assumptions and you get much better output of the this thing. Okay. There is a lot of LLMs available. Okay. Which LLM to use is your choice. In fact, what you can do is, what like they go to few popular websites like LM Arena, right? They rank these LLMs based upon these performances, and these ranks get updated weekly. Okay, for example, if you go to this leadership poll, and for agents, right? As of this week, Claude Fable 5, which is having restricted access, is having the best performance for building agents. For building chat model, text-to-text model, so if I click text-to-text model, as of this week, again, Claude Fable 5 is the highest rated. In fact, Claude leads majority of this. The open source one comes somewhere here. GLM 5.1 is an open source from MIT, comes at the 15th rank for creating text-to-text models. For image generation, text-to-image generation, GPT-2, Image 2 from OpenAI is the top rated panel this week. All right. So there are many LLM models that are there. You can use it, any LLM model. And there are models which are fine-tuned. Let me show you that also. Where is that? I'll go back.
Isn't Fable 5 kind of discontinued because of the US government issue?
Yep. I don't know how it is listed in ranking. I have no idea.
It's still showing number 1 there, yeah?
Exactly. So let me just search for. There you go. So now this is Hugging Face, right? Hugging Face hosts many open source models. If I search for, I'm just searching Python as the model. This Gwen 3.5 version 9 billion model is fine-tuned for Python. Meaning they have taken this large language model and then they have fine-tuned it to write Python codes. So if you have used this model versus a generic model, this model would write a much better Python codes for you than other models. Okay, so if you are doing vibe coding, please keep this in mind. Use a model which is fine-tuned to write your particular code. The proprietary ones which you use in GitHub Copilots, in your Copilots, are proprietary ones. But if you are writing your own algorithm for your company and you want to host it locally in your server, and it's better to use a model which is fine-tuned to write for that particular purpose. Okay, right. So now where am I? Prompting matters because GPT-5, the input tokens that you give for each million input token, this is the current price, $1.25. The output tokens, which is a lot, which gives a much verbose output, for a million tokens, the output cost is $10. That's a lot more expensive. Okay, and the problem with the vibe coding, and if you guys are at the manager level, the problem with the vibe coding is you ask a simple question, it writes hundreds and hundreds of lines of codes. Okay, and all these codes are cost for you, and by proper prompting you can reduce this cost. Okay, now you give a prompt, this goes to this LLM, and the LLM generates the response. Correct. And just like any human, your communication to this LLM matters. So if you have a clear context and specificity to it, then your LLMs can give a much better response to it. Okay. This is where your prompting strategies comes in. Do you guys aware about any prompting strategies? There are every day there is new prompting strategy comes in. And if I want me to cover all the prompting strategies, that's completely impossible to do it. But there are some few popular prompting strategies. Anyone has aware about any prompting strategy?
Multi-shot, meta prompting, so on and so forth.
Meta prompting, did you say?
Yeah, meta prompting, multi-shot prompting, so
Multi-shot
on and so
prompting.
forth.
Markdown.
Markdown is the file. But yeah, so you can save your skills in that. Yeah.
Chain of thoughts.
Chain of thoughts, right? Right. It's a very common prompting strategy. What I
Then
do, yeah,
recursion of thoughts, same kind of.
recursive prompting technique, right?
Yeah.
So let me give some examples here. Okay. Maybe I'll spend like 15 minutes on that before I go into actual vibe coding part. So your promptings can be instructions and example based. Okay, some of the examples of this is zero shot prompting, one shot prompting, few shot prompting, or it can be iterative and refinement based. Some of the examples is your reusable prompting template, meta prompting, iterative and self-critic kind of a prompting, or it can be reasoning and process oriented. Some of the examples are your chain of thought prompting, stepwise reasoning or react prompting, or it can be context and role based prompting, or it can be something like a role based prompting methods. I will give you some examples and then I will ask you to write some more examples. Remember, it's not like we start with the it's not like once you start communicating with an LLM, you should not it's not like you should always follow a particular prompting technique. You can start with a zero shot prompting, and from there you can switch to chain of thought prompting, and from there you can switch to something like a reusable template prompting. So within a session you can mix and match these prompting methods. It's not like in each session you have to follow only one particular prompting technique, right? So let's look at some examples. Zero shot prompting, you ask directly without any examples. You ask the question and the LLM gives a response. What I mean by that is, let's take one example. Summarize this change request in 5 bullet points. Write the scope, risk, dependencies, and then rollbacks. So as a developer, let's say somebody has given a change request, and I ask you to LLM to give me the change request and ask me to give it in 5 bullet points. These are the 5 bullet points it will give. It will give scope, risk, dependencies, rollouts, and rollbacks. Okay, when to use? These are simple. If you want to summarize something, if you want to rewrite something, if you want to extract something, that's when you use it. The problem with this zero shot tip, it is a bit ambiguous and it can give inconsistent outputs. Okay. Another prompting technique is your few shot prompting. In few shot prompting, you will give some examples. I'll give an example. So let's say here is a requirement and here is my test case. So you will give one example and here is the requirement comes like this. These are the test cases I have written for this requirement. Okay, you give few examples like that and then ask it to give another new requirement. Ask it to write a test case. So it learns from your example. It learns from your examples and then gives your output. With this, your ambiguity will come down and your response will be much more concise. Okay, so this type of, if you give one example, then it is called one shot prompting. If you give two examples, then it is two shot prompting. More than two, it is called few shot prompting. Here is my question. This is how you should respond. This is my question. This is my response. Now, given the new question, what is my response? You ask that, it will give an answer to it. This is called few shot prompting. Then you have a chain of thought prompting. Okay. Example for the chain of prompting is list the steps for this data pipeline, then state 5 tests with ratio. Okay. What you do is you ask step by step. First, you ask it to give me one output. Then you ask it to give more outputs based on that. So you limit your response. Okay. It's not like it will give a much. If you ask it to give the response, it will say that verbose all the response. Instead of that, you are asking it to give a step-by-step response. Okay, here is my question. Give me an answer to this step by step. First, give me first step. Once you give the first step, then give me the second step. So list this action step by step so that your response is much better and then much concise. Right? Then you have a role-based prompting. In role-based prompting, you ask the LLM to put itself in a particular shoes. So let's say that as a reviewer, act as a security-focused reviewer, and tell me what are the risks, unsafe evaluations, and unbound joins in my codes. Or act as a product manager and give me what is the scope of this particular product. Act as a CTO and tell me what is this newer technologies that can be added to this particular business. Right? So you give a role to an LLM and ask it to play that particular role. It will wear that particular hat and give you the response. So that's a role-based prompting. Iterative prompting, you can say that, hey, you can be a critic of yourself. Okay, so let's say you ask a LLM to write an RFP for you. Okay, you ask it to write an RFP, and you ask the same LLM to be a critic of the RFP that you have written and make a reversion and then give it back to you. And it will tell you the critic, okay, this is where it does, this is where it meets the criteria, it doesn't match the criteria. So you can also define the rubrics also to it. Hey, now you are given the RFP. This is the rubric on which I want you to be critic on yourself and tell me based on this whether you are met this criteria or not. So its own draft, it can review and then give you a much better concise output. This is an iterative type of prompting. Another is your reusable prompting technique. This is where your coders will come into the play, where they will put a particular kind of a template being written in a JSON file or written as a Python code, and that has been reused every time you call that particular function. Okay, we can give a role to it, we can give a task to it, we can give a constraints to it. So all this can be a reusable templates that we can be given to it written in a code, and that can be used to call again and again. Okay, now let's do some small activity. I don't know how much time there am. Oh, 8 o'clock. Okay, I have half an hour. Okay, I'm very slow. I have to cover a lot of ground. So let's say if I ask you to write a short internal email announcing a new training session, this is the what I want to do. Now, if I ask you to write as a zero-shot prompting, how do you would ask it? What would be the prompt? Am I clear on myself?
You can just ask, write an email about so and so.
Just that, right?
I think maybe give some context in terms of what the training is about, what the schedule will be. I don't know. It depends on what kind of email we are writing, right?
Right. So
That's more detail, I guess.
yeah. So you can give. Yes, you can give. Actually, nothing wrong in that. As long as you can say that, hey, I am conducting a session on Gen AI for my managers. Write a short email regarding this to explaining this. This is what the training is all about, and here is the venue and date. That's a zero-shot kind of a prompting. I did not give any example to it. Okay, or you can give a one-shot example or a few short examples. Meaning, you can take a previous email that has been written. Last time, for some activity, you have written an internal email. You copy paste that email. And now you say that, hey, this is the last time I wrote an email for other activity. Here is the another training program that I'm going to conduct. Similarly, how you have written the previous email, write the same. That becomes your one-shot kind of a prompting technique. Okay. Then you have a chain of thought prompting, where you can say that, hey, here is the training program that I am going to that will be conducted. I want you to write an email. Now think step by step what and all you would write in this email. So the LLM will give that, hey, email should have this. And then you go and then say that, okay, I like this part. make this as a body, make this as a subject header, and then address, instead of saying, dear colleagues, you want to write it as something else. Okay, hey folks, you want to keep it much more friendly. So you can say that, hey, don't use the word, a salutation, dear colleagues, use hey folks, and then write an email. So that becomes a chain of thought kind of a prompting. Other way is role-based prompting. You can say that, hey, I'm a HR manager. I'm writing this email. Write this email for this training activity. Then you would write an email as if like a HR person. Or you can have a follow-up prompting. So you can just start with a zero-shot prompting, and then you can say that, hey, I did not like this thing. Make this critique, make these changes, and then try to give me a better draft in the next iteration. So it will give a better draft in the next iteration. So here is an example that I have been written, pre-written. Zero-shot prompting. Let's say I'm writing, hey, I'm using a Gen AI to improve daily productivity. Write an email about this. Write an internal email announcing the training on using Gen AI to improve the training productivity. This is zero-shot example. One-shot example, something like that. Few-shot example like that. Role-based, iterative. So based upon your prompting technique, you can make your answers to be concise and make it your response to be less verbose. Okay, how to make the AI to have a less verbose, much more focused answer is called harness engineering, and people are spending a lot more time on the harness engineering. If you have time, please Google it and then see. That's the next big thing that is coming up. There is a lot of
Sorry,
papers.
what was the name you said? What engineering?
Harness, HARNESS.
Harness.
Yeah. Harness engineering. Yeah. Okay. Are we good? Till this part, I did not even cover coding. Oh my god, I have very little time. Okay, let me see how this goes. Till this part, what I have done is, I said a couple of things. We understood how the LLM works. LLM predicts one token at a time. Okay. And then I said that since LLM understands the language better, and the LLM is very poor in generating codes, it's very difficult to do a vibe coding with LLM. But still LLM does. How can we generate better codes with LLM is the question. Second thing I said is, to get a better response from the LLMs, you're prompting method. And there are different prompting techniques exist. So by these two understanding, we are going to generate some codes here. And let's see how we can generate those scripts. Okay. Next phrase on prompt engineering. Okay, so what is the question? Harness engineering. Yes. That's what it is. Right. So this is the next big thing that is being coming up. So people talked about prompt engineering, then they talked about context engineering, but now it is all about harness engineering. Okay. Anyhow, that's slightly out of the topic for today's class. Okay, let's get to this. I said prompting matters. Okay, but we looked at different prompting techniques. But whenever we talk to an LLM model, we cannot directly have this in the back of our mind, especially as a programmer. So I myself come from a developing background. So especially if you are a developer, and then if you are writing the codes, I can't keep this in back of our mind and then go with this prompting techniques. Right? So what I do is a much better, simpler way to write better prompts is what I do with this. So I created this image using Gemini a couple of years ago or 1 year ago. Okay, because this is 1 year old slides and I'm reusing my slides. Okay, everyone does that, right? So I'm reusing my slides. 1 year ago, I created the slides. Okay, how did I create this image in Gemini? I did something like this. I went to ChatGPT and I wrote this prompt. What I wrote is this. I need to create a comic style image where on the left, a AI scientist is controlling a robot. On the right, a robot is controlling it. Right? The joke I want to communicate is the data scientists thought they would control the AI, but at places AI is taking the jobs, and I don't know. AI is taking the jobs. This is the joke I want to communicate. And I said that I don't need an image, just give me the prompt. So what I'm doing is, I'm asking AI, LLM, to write a prompt for me. I'm not writing the prompt. I'm asking an LLM to write a prompt for me. What I usually do is, I go to one particular LLM, get a better prompt, and copy paste in a different LLM. I can do that. Or I can ask the same LLM to write a better prompt for me and use that prompt to generate codes for me. So in this case, I went to ChatGPT. I typed this. What came out is this. Look at this ChatGPT output. This I would have never thought to write something prompt like this. Look at this. It's a comic style illustration, split into two panels. In the left panel, an AI scientist in a lab coat. I never said lab coat at all. In the left panel, a lab coat with glasses, happily controlling a humanized robot, using a joystick, levers or laptop, symbolizing that humans thought they would control AI. In the right panel, you create a humanized robot, now controlling a smaller version of AI scientist, like a puppet, with the strings or joysticks. I never mentioned all these things. And it said that the style should be humorous, comic, bolding outlines, simple, flat with clear expressions, scientist confident on the left, worried on the right. All that expressions also is being said. So I would have never wrote this kind of a detailed prompt to get me an output. Okay, if you would have started with this prompt and if you would have given this, I might have still got an image, but not at this levels of detail. I got these levels of details because I asked LLM to generate a prompt for me. The LLM generated a prompt, and I used LLM generated prompt to create an image, and I got a much better image. Right? So any comments? I'm looking at it. Okay, OpenAI harness indexing.
Can we look at the comic again? Can we go back to the slide for the comic?
1 second. I will go back. Look at that. Right? We can do this live also. I mean, this is created a year ago, right? Let's start with this prompt. And let's go to an LLM. Let's do two things. I give this prompt. Did I copy paste it? I did not copy paste it. I click copy, come here, paste. Okay. Now I do this. So I'm asking it to only create a prompt for me. Let's see what is the kind of prompt that it gives out. And by the way, I am using a OpenAI GPT 5.5 model, a reason model. And look at that, much similar output comes in. Create a comic slide split panel illustration with a humorous corporate tech team. I did not say that. An AI scientist, a data scientist in a lab coat, confidently controlling a friendly humanoid robot. In the right panel, the situation is reversed. And you can see that they make this image professional enough for a classroom presentation slide. Avoid dark and scary visuals. Keep the tone witty, light, and thought-provoking. You can also use now it is giving a shorter version. You can use a shorter version also. Create a two-panel image. On the left side, a confident data scientist controlling a robot through an AI console with a caption. I did not even give a caption. We thought we would control the AI. On the right side, the robots controlling this. So you see that the prompting gets better the moment I ask LLM to generate a prompt for me. So I can use this prompt to create an image here. So I just copy pasted this prompt now. Now let's see what kind of image comes out here. Now this would be a much better image than what I have written as the initial prompt. Right? It's taking a bit of time because I use a intelligent model to create it. And let's see what kind of image comes up. Still time taking. Okay. But how many of you do that? How many of you have done this? You have taken an image, or rather, you have asked an LLM to write a prompt for you. I do that a lot.
I usually do it. And the better part is you can even write that I want a prompt. So on the chat GPT, you can write I want a prompt for Gemini.
Yeah, you can do
So
that.
it gives Gemini customized. But again, at the end, it will suggest if you're okay, I can also generate this.
Okay. They don't want. They don't want out of this.
Yeah.
So I mean, all these are there. All these people talk a lot, right? But end of the day, what I feel is asking an LLM to write a prompt for you is much better task than me thinking about all these things, right? So let's do some coding now. Let's take this. I need a prompt, just like what Gautam mentioned. I need a prompt that I can copy paste in Claude. I want a browser-based output. The concept is diversification your stocks. Okay, diversification stocks reduces the risk when things are not correlated. Demo is simple. You do a simple scatter plot where you generate a synthetic stock returns for two equities in different colors, and use React or Chat.js component in the Claude artifact with a slider to show the correlation. Okay, let's take this, and then I copy paste this in ChatGPT and see what comes out. Till that, I hope my image is created. Wow, there you go. Oh, much better image than last time. I would have not created this nice looking prompt with my prompt. So I refined my prompt. That's why I got this much better output here. I should save this somewhere so that I can use it in the next class. Right? Okay. Let me go to this new chat and let me copy paste this chat. I need a prompt that I can paste in Claude. I want the browser based output. This is the prompt I'm copy pasting it. So let me use a slightly instant model. I don't want to waste time. Right. Look at the prompt now. Create a browser-based cloud artifact. Build an interactive demo with the following. Generate synthetic stocks, synthetic returns for two equities, stock A and stock B, with 100 data points. I did not give all these mentions. And the ranges should slide from +1 to -1. Default should be 0. Label should show current correlation value. Show a scatter plot with x-axis showing A returns, y-axis showing B returns. Add a simple portfolio risk explainer. Add a small volatility calculator, and make the output to be clean, class 1 friendly, blah blah blah. Right? I never said all these things. It understood that I am taking a lot of classes. That's why it says class 1 friendly. Now I go here. I paste this in Claude. By the way, I don't have a premium version of the Claude. I need to. Table 5 is currently unavailable. Oh, okay, not like this. So I copy paste this, and I use HiQ 4.5 model, and let's see what it comes up. Copy paste this, and it is doing this thing, and this will bend things. One of the major advantage of your vibe coding is vibe coding. You can use it to generate some quick prototypes that you can show it to your teams. I believe many of you are not developers, right? So if you want to quickly show something, an idea, you can put this idea into one of the LLMs. Ask the LLMs to create a codes for you, and let the LLMs write the codes for you, and then generate, and then build something like this, and quickly show it to your team, so that your team can use this to show the demo. Okay.
Actually, Claude creates a lot of very good HTML demos, and I've used it for prototyping and defining the workflows. It works very fine.
Yes. What happened to me? Where is the artifact? Okay. Sorry. Where is the artifact? Last time I created, and I have that copy pasted it here. Look at this. I hope it works. Here you go. This is what last class I created, right? The same thing. So you have already created two stocks. This is asset 1 and asset 2 and asset 3. You can see that asset 1 is going down, asset 2 is going up. So my stocks are uncorrelated now. So my volatility index is low, portfolio volatility index. But if you have the stocks to be highly correlated, meaning if one stock is going down, other stock is also going down, then you have the volatility index to be going up. If the stocks are uncorrelated, then the stock volatility index should go down, meaning it is not my returns are not affected too much because one is going down, other is going up. So it's still I make not much of money, but still I make I not lost too much of money. So you can see that you can create some quick artifacts like this using vibe coding. And like I told you, remember your prompting matters, and you cannot write these kind of a detailed prompts. So use LLMs to write a prompts for you. Usually what I will do is, I will not directly copy paste this prompt into the Claude. The moment I copy paste that prompt, I would go to Notepad and I will paste the output in the Notepad like that, and I will read it. Wherever I want to make changes, I will make changes. That one I will paste it in the LLM to produce codes for me. Okay, let's take another example. Okay, here is another example. Again, I did the same thing. Went to Claude. This time, or Claude, I don't remember ChatGPT or Claude, and I said that instead of me creating artifacts, give me a collab notebook. I don't know how many of you know Google Collab notebook. It's where you write codes and mark down comments. And I said that, hey, now you take stocks, 3 stocks, Apple, Microsoft, and JP Morgan, and then plot the daily returns around the major dates. Okay, the major dates can be your major announcement dates. Like for example, Apple launches a new iPhone. That can be a major announcement date, or it can be your FOMO meetings happen immediately after that. I want to see how the stocks went up or down. So you plot the daily return 3 days before the meeting, 3 days after the meeting, and I want to see how the stocks is bounced back after this major return. This is what I want to plot and then see, and I want it as a Google Colab notebook, meaning codes. And it created again, I took this code prompt, copy pasted in a GPT or Gemini. Then I copy pasted in another LLM to create a codes, and that one gave an output something like that. None of a single line is been written by me. Let me click it. It's worked a while ago. None of this is written by me. Okay, all these codes are written by LLM. So the LLM automatically installed all the required packages for me in Python. It took these 3 stocks, and then it took the start date and end date, and it says that adjust if needed. It took the opening price, the high price, low price, and volumes, and then it looked at first few data, and then it looked at the major events. The major events again for 2024, like I told you, it is created 1 year ago. 2 years ago. I've been reusing the same thing, but it automatically looked at the major events for Apple, Microsoft, and JP Morgan from the internet, and then it plotted it around those dates. Okay, so this is for Apple. This is the major event date. So this is the 5 days price before that, and 5 days price after that. This is immediately after the Apple announced the new iPhone. Immediately the price went up the next day, and then the day next to that they realized that iPhone is exactly 16 is exactly same like iPhone 15. So the price dropped, and then it rebounded. Similarly, look at that. This is for Microsoft, not so exciting product. So the price did not go up; it went down. This is for JP Morgan, maybe after their meeting. So the price went up immediately after the meeting. So I did not plot any of this. All these codes were written completely AI generated. Again, for a generating AI generated codes, copy paste your prompts would make much more sense. The third example, this is my last example. I wanted a fully developed app that I can write and then run it in my VS Code. So I started with this something like this. Let's build a nice app. Same example. Let's build a nice app and do not be verbose. You see that I have been instructing it. Do not be verbose. Be concise and answer to me what I ask. The concept is this: I want to build a portfolio assistant, and I want to build a nicely engineering folder structure, the files with good comments, and I'm going to use a VS Code and write a Python functions. And then I give my local path also and create a dump CSV file with stickers in it so that I can upload the stickers and then it should work automatically. Right? So I copy pasted this code and then prompt, and I asked it to write a prompt. Let me see if I can fetch that prompt. Somewhere I have it. Okay, I have it somewhere here. Grad. Oops. Vibe coding maybe. Yeah. That is the prompt that it gave me. Now it automatically gave me the role-based prompting. Look at that. You are a senior Python full stack engineer. Role-based prompting. I did not give that. That is the prompt I gave. This is the output it gave. It automatically gave what should be the folder structures, how it should be. Inside each folder structures, how the folders function should look like. And all this big instructions that is given. I just copy pasted this prompt in the code, and then I got the output. Let me show how the output looks like. None of this, again, none of the codes is written by me, completely written by Claude. That is the file structure that has been written. So inside SRC, you see that all these codes were written completely by the AI. Where is it? Sorry. Oops. Were completely written by the AI. Data loader is written by AI. LLM assistant is written by AI. All these things are written completely by the AI. All I have to do is just run this application. Okay. So for example, if I run Python run Streamlit app, this should completely give me a working model for me. Look at that. I just copy that and paste it somewhere. And I should give me a completely working app for me. There you go. Portfolio Risk Prevention Manager. All I have to do is upload my CSV file, and then that should give me the portfolio analysis for me. Right? So writing an AI generated code, again, I stress on the point, your prompting matters. Based on the prompting, you can generate the AI written codes to create a quick prototypes. Yes, you have a question.
So, it could be a same prompt given to the same LLM model or to two different models. But what I've observed is the output varies. I mean, if I, let's say, do sequence 1, the output is different compared to sequence 2 for the same prompt for the same LLM model. The challenge is that if I want to integrate, let's say, one of the LLM models to do something for my business application, unless and until there is consistency and I can be sure about the output, it's difficult to then trust this model. So, I mean, why does that happen, and is there something being done to address that?
Let me clear it up. Look, your outputs will be different. It doesn't matter whichever LLM model you use. You ask the same LLM model, same prompt multiple times, outputs would be different. Okay, it's just like I ask you to explain me some difficult concept to me. Okay, let's say I ask you to explain LLMs to me with your understanding. you would explain to me in certain words. A minute later, I ask you to explain the same thing back to me. Would you explain that back to me in the same words?
Yeah, I mean, from that analogy, yes, I may not be using the same words, but conceptually, I may be explaining the same.
Absolutely. That's what you need to look at. You need to look at it whether the conceptually the LLM is giving the right answer or wrong.
Okay. Now,
Okay.
Professor, just want to add.
Sorry, Ravi,
Yeah,
one
sorry,
second.
go ahead, Vikas.
Just want to extend that. So I agree, from an explanation point of view, that is okay. But if I'm asking it to give me a data point, but that data point also differs.
Okay. So this is the challenge, right? There are multiple things we would do. See, we have a probabilistic model in our hand, and we have been used to writing codes which is deterministic in nature. If I run this loop, I know what happens. If I run
Yeah,
this
right.
question, I know what happens. Now you are given me a probabilistic model and asking me to integrate into a deterministic software. That's a challenge, right? I in fact, that's a training.
May I?
Yes, please go ahead. Someone have an answer to it.
Yeah. So, because to that is the same thing. When you're going for a meeting, if we want something quickly, okay, ask for Copilot or something. But when you want to repeat the same thing in every maturity meeting or in an exec meeting, we can't use this Copilot. So, the challenge now is to use the Copilot, then create a script which can replicate that particular output, and then work on the code, and then later use that code to replicate the same data point. So basically, from any LLM model, what I realize is, as mentioned, there's no output even after 1 second. I can type the same thing once and then get output, and again I press enter with the same copy paste. It's giving different answer for the same question, even though how much specific we are with the data point, that is input point.
I'll
Like,
give you example. I'll give you example why I'm saying. Let's take an example where you are creating a model to integrate with an application, where I give the task of giving me a market value of, let's say, a mortgage or a property. It could be a commercial property, based on certain parameters like a property type or the size of the property and number of bedrooms, etc. Now, the value you get for the same prompt and for the same Ford is different every time. So how does if I give it to the customer, how does the customer trust that? Because they cannot then make trust that value to on their lending for the
it's
lending to
not,
the customer.
yeah, correct. It's not deterministic. That exactly the end user, you will not be able to replicate the answers or get the same answer again. So that's why we can use it as a starter point in order to get a particular method of find a deterministic way to get an output for this, and then use that particular output in order to every time get what do you say, a stable answer or the input answer. But then with contextual, I am also having the same challenge. So given that in the companies they are saying that you have all the tools now, we should be able to get the answer faster, but then it's only getting harder because they are getting a lot of answers and somebody can give instant reply. But then tomorrow somebody comes back and say like, because you told me last day for 4 bhk, and then I did these analysis, but then I come back today and I'm getting different output.
Yeah.
We are stuck because we cannot give that answer, and it's getting harder and harder with upper management to what do you say, mm, mention this or to put
Yeah,
this.
because there is a mismatch in expectation, right? Higher management expects that now there is AI, so there is a solution for everything. But
Yes.
you have to understand the
Sorry,
context.
sorry to cut you off. I have an answer to it, but I like it because you guys are going to be a leaders in the next email. You guys are already a leader, and you are understanding the struggle. But let me take the viewpoint from a couple of more people raise their hands, and then I give you an answer to this question: how to deal with these things. Ravi and Eric, Eric, right? Yeah. I assume yes.
Yeah.
Is right.
So, Professor, is it because the LLMs are continuously getting updated, and that is where the issue is because it's inconsistent or maybe different responses?
LLMs are probabilistic in nature. Period.
Okay.
You cannot. It will not generate the same tokens every time unless you keep the temperature to be very low. Those are the things that we will talk in subsequent classes. But LLMs are probabilistic in nature. Period.
Okay. Oh, got it.
Is this Eric? Eric is yes silent there. Eric Hagin.
No, it's asterisk.
Eric. Okay, sorry about that. Yeah. So go ahead.
Just 2 points. One, I've had the issue whereby it is I put the data into Claude and then put it into Copilot, and Copilot gave me a response basically that the data that I got from the other LLM, they shut it down. They don't know what they're talking about and produce something else different. And secondly, on what Vikas was saying, in terms of using it in the property type, two scenarios can play off. Is the data in their model static, or if their model is actually pulling real-time data? And if it's pulling real-time data, it goes into the aspect of economics dealing with hedonistic models in property valuations. And our property valuations is actually subjective. And it breaks down the characteristic of each property. And that's where, according to that time, according to your model, your values will change.
Yep. Absolutely. My answer is to that is right. Because let's do the same exercise. Let's go to two LLM models. You ask the same question, but now you ask the LLM before you respond back to me. Tell me what are the assumptions you have made and walk me through step by step. How did you arrive at this particular conclusion? You do that. You correct the assumptions. You ask it to give me step by step response. You will most likely to arrive to the similar answer in both the LLMs. We can, I mean, time permits, we can try this in on class. We can go to two different LLMs and ask it to show me step by step what it is doing. Break it down into small steps. That's the concept. Break it down into small steps. Ask it to show me step by step what you do. What are the assumptions you made? Tell me before you proceed to the next step. Once I say okay, then only you will say to go to the next step. You do this, you follow the same process in two different LLMs, you will get similar, more or less similar answer. So it's the only way you can make the LLMs to be more and more deterministic is by breaking down into smaller steps. And that let's, I mean, if time permits, we can do that. If not, I mean, I don't think I have time. And that's exactly what I've been trying to say. So these kind of a code generations, vibe code generations, is good to go for prototyping. But vibe coding by this method is absolutely chaotic for a developer. Like take Priya for example, she would struggle, right? She's been struggling. This is not the way to go in vibe coding for the developer. Do not do this. Okay, what developers has to do is break it down to steps. Right? Writing this something like this is a child's play. We can make it. The whole file is written by that. 100 lines of code is done. But engineers, they won't do like that. Developers won't do like that. What we do is, let's say, a more childish way of writing prompt, I would say, is write a Python function that reads a CSV file of the user and returns only the activity. If I give this to an LLM, this is what LLM gave and response. And it works. Nothing wrong in that. Nothing wrong in that. It works. If I run this code, it absolutely works. But let me ask Priya, what is the problem with this? Is there any comments written in the code? Does the code says what this particular function does? Does this code has any test cases written on it? There is no test cases written on it. There is no comments written on it. Nothing is written on it, but the code works. So if I am a developer I would write something like this. I would write. So the problem with this is in this Python code, only the functional signatures, what type of these things, what type of parameters should be goes, what the edge cases should be, nothing has been written. Okay, a proper developer written code would be something. See the difference. This is comments. It reads a CSV file of a user and returns only the active cases. The file path must be str, string. The path to the CSV file should contain user data. CSV must be is active column should be there, and it returns what you call it as the list and dictionary. This is the way code that we wanted, not this working code. It gives working code, but the problem with that is working code is not a final code. The problem with this is not well defined. So what I would do first is, and all these test cases is missing in this code. These are the test cases. It tests whether the active codes are working or not. It tests this is the user ID, what should be the output. All these test cases are missing in the developers. Okay. So what I would do is, first I would start with something like this. I will define the problem to an LLM. And I will ask the LLM to first write the doc strings for me. This is called doc strings, meaning comments. I will ask it to write first the comments for me. Explain to me, you are writing a function. Explain to me in a simple English what this function does. That's what comments mean. Okay, this is the comment. This function reads a CSV file and returns only the active users. This is the parameters it takes. File input is the parameter, and the file input should be string. The part should be in the CSV file. It returns the list of dictionaries. And if the file is not found, it raises an error saying that CSV is not found. Why I am asking it to write it in English first? Because LLM is good in generating English. So first thing I would do is I give a problem. I will first ask it to write the doc strings for me. The moment it writes the doc string for me, okay, I would write something prompt like this. You are an expert Python developer. I will provide a problem or a function idea. Your task is to implement it step by steps. Look at that. And I say, do not combine steps or extra content. Respond only with request output for each step and wait for my approval. And I would say, proceed to next step before you going forward. And then I will put my problem here. Okay. And I say, step 1, generate only the functional signatures or doc strings. Tell me what the function does. Tell me how the parameters are handled. Tell me how the values are returned. Tell me what are the side problems effects that I can get. Tell me the behavioral norms. Include the usage of doc strings if possible. Do not write the function now. Don't write the code yet. Give me what the code does, that function does. First tell me in English. I will see that. Once I'm happy with that, then I will go to steps 2. I will refine those English words because LLM is good in English. It understands English well. Now, based upon my steps, once I define my step 1, once my doc string are right, then I would say, hey, now this is what the function should do. Now write the base cases, edge cases, and the exception cases for me. Don't write the function. Tell me what should be the base case for this. Tell me what should be the edge case for this. Tell me what should be the exceptional case for this. Still write the doc strings. Still do not implement the function yet. This is my second step. Once I'm happy with these 2 steps, now with the test cases, doc strings that I created in step 1 and the test cases that is created in the test 2, now generate the complete implementation. Okay. Now only give me the output from the current step. Don't include the steps from the previous side. That I know. I already corrected that. Step 1 and step 2, I made sure that it's working fine. Now give me the codes. Now it will generate the function. So you see that I'm going step by step. I'm asking it first to write a simple plain language English explanation of what is the code you are going to write, which is called doc string. Once your doc strings are written, then I ask it how this function is going to behave. So those are your test cases and edge cases and connect cases. Then once I'm clear with this, then I ask it to write a function. And I will not write whole codes in one go. I will go function by function. So if you are a developer, A developer needs to write, should not write, hey, this is my task, this is my whole requirement, write the complete code for me, will completely go haywire. Whereas if you write function by function, 10 lines codes, and each 10-line codes are properly generated with clear cases. First, it explains to me in English, it explains what it does, then you write the 10 codes. Now you put the 10 codes. Then ask it to write the next set of 10 codes. Before you write it, ask it to first explain to me in English what it does. Then you refine that English. Then it asks you to write the codes. Then it would do better job for you.
Is that what a iterative kind of a prompting would be?
Step by step iterative prompting
Step
it
by
would
step.
be. Right? That is what is best way to write a vibe coding for a developer. Okay. If you are not a developer, I don't understand anything about code. You can write, refine your prompt, go to an LLM, refine your prompt, copy paste the prompt in another LLM, it will work. Or even go to your Copilot, write your prompt, ask your prompt to refine your prompt for you. First, refine the prompt, get a better prompt, read the prompt, see where you want to make the changes, copy paste the prompt, it will write the codes for you. No problem. It will definitely give a working code. No issues in it. It will work on a first go. But the problem is the moment it comes to the integration. Now that's where you have to break it down to a simple steps. If you break it down to a simple steps, ask it to first explain me in English what it does. Then you go on to explain your codes, then it would work. Okay, so first you define the correctness of the code. Explain clearly what is your constraint. And when it goes wrong, and this is another problem, when it goes wrong, do not fix your code. The problem with many of the developers is the AI will give you the code. The developers are very good in knowing the codes because they have been writing these codes for past 10 years. The moment they look at the code, they know where the problem is. They will fix the code. Okay, they will fix the first 10 lines of the code. Then ask the AI to generate the another 10 lines of the code. The AI is not aware what you fixed. Okay, the AI is not aware what you fixed. It will assume whatever it generated, the code is what it generated, and it will continue to give that code. Okay, so do not fix the code, fix your instruction, and let the AI figure out the right way of writing it. Okay, unless you do this, that becomes a problematic. Now the question comes is, I will stop here. I don't want to go any further with this class, and I will take questions. We'll have a discussion. Another problem with this is you have a legacy code, which is 2000 lines of codes. And I told you, AI is very poor in reading the codes. Even a fine-tuned model would fail there because the codes does not have proper instructions, the codes does not have proper comments on it. It would fail. So if you are integrating your old codes into your new code and you want to attach a new module to your old code, first fix your old code. Okay, go to your old code. Explain it, write it in a clear English comments. The following lines of codes discuss. Write your doc strings there. Clearly explain what the each function does. Write it in English so that when the AI reads your code, it reads your comments as well and understands what it is. And ask
Probably
your,
rewriting it from scratch is easier than doing all of that.
sometimes, yes, it does. What we do is this. We give the legacy code, we make it slightly automated. We give the legacy code to the AI and ask AI to write the comments for me. Don't modify the code, just write the comments for me and give it back to me. Now, I have the comments. I let the developer to read the comments and fix the comments if there is an error. Okay. Once they do it, then I have this legacy codes with comments. Previously without comments, now with comments. First draft is given by AI, vetted by human. Now that is a completely commented codes. Then once I have this, and again I go back to AI, and I ask AI to create a mental map of which code is connected to which code, which file is connected to which file, where the handshake happens. I ask AI to give me the first draft of it. Then I go back to the developers and I give the developers the first copy, ask them to vet it. Because they have been dealing with these codes for many years, they would vet it. Once I have this clear picture of handshakes where the codes are handshakes happen, and once I have a legacy code with proper comments, then I ask the developers to follow this technique to continue developing the codes for the legacy codes if they want to attach a new module. Or else it becomes really difficult. You cannot just directly jump in. Hey, today I got a Copilot access for you. I want output in 1 week. It might not happen. What would happen is this. What is the realistic ask is this. Previously, it takes 3 months to write the codes for you. Now it would take 2 months to write a code for you. So it is realistically expecting a 30%, lesser time frame is okay to ask for, not something like drastic 50% or 80% improvement in the time. It's too difficult to ask for. Yes, question, yeah.
My question is, look, being not of a technical background, if I want to develop like a small app or an HTML web page, or would I be able to do that, or do I need to develop or build some technical skills or development skills? Or
absolutely, you can do it. Like I told you, first refine your prompt and ask LLM to give me the codes, and ask LLM to step by step walk you through and how to implement the codes and how to run the codes. LLM will help you on that. Only thing is, you be very clear on your prompting, and as a non-technical person, writing those kind of a clear prompts will be really, really difficult for you. So let the LLM write the prompt for you. Refine your prompts, and then from there you can write your codes.
And it doesn't matter which model to go for, or would it make any difference?
If you are not a technical person, just go with the popular model. If you are a technical person, go with the fine-tuned model.
And with my last question, would this make the job of a code tester redundant?
Good question. Maybe is the answer. It would make the code tester job to be much faster. Yes, I do agree on that point. I don't think it would make it redundant as of now. Maybe in future it may make it redundant. Yeah.
Thank you.
I have a question.
Yes, please go ahead.
So vibe coding seems pretty straightforward. It seems pretty easy, and many people can leverage it. What is the point now of doing it manually, of doing manual coding if you can do this?
Okay, I don't think so. I mean, I've been vibe coding since 2 years now. Okay, I stopped doing manual coding, and I do go to trainings, a lot of trainings, and I encourage people to do vibe coding, not using writing thousands of lines together, but something like what I said. First, write the instructions clearly, ask it to generate code step by step. You still need a coder to understand the codes. I won't say the coder's job becomes redundant now. The coding is, there are a set of codes written there. For a non-technical person, we don't know what is the set of code does. You still need a person, a coder, to go there and see what it makes sense, whether it makes sense or not. So the coders is still there, very much in picture, but it's just that the coder's job has become a lot more easier with in recent days.
Right. Okay. Thank you, Professor.
I have an issue to raise. I mean, the
Yes,
problem of vibe coding is that you're training someone else's machine. So you start off with your own IP, your own idea, but your idea now transmit to someone else, and your competitor can easily use your idea based on their understanding to duplicate, and his result may be better than yours. So you're losing your competitiveness. So what must we do?
Yep. So that's an issue. That's the issue with anything, right? It doesn't need to be only your LLM, right? Like for example, if you're doing a market research, right, and you have a product idea, a novel product idea, and you are asking an LLM about inputs about this novel product idea, which is not even patented. What if this information is stored somewhere else, and what if it has been used somewhere else? I have no idea. This is a problem with anything, not just with their coding, right? The answer to that is, if possible, try to use a offline LLM model. When I say offline LLM model, these models are already pre-trained and hosted in Hugging Face and things like that. You can download this model and run it on your local so that your data doesn't get transmitted outside your computer. And that's the only answer I have to it. But having said that, LLMs do say that. I mean, you go to ChatGPT or Claude, they do say that they don't use your personal data, or they use only the de-identified data for training the LLM models. But the risk that is always there. And I don't think I'm the right person to answer this. There is a course on separately for in your DBA on ethics and LLM or something like that, where these things being talked a lot on this part. So there's a legal persons who deal with this information. I hope I answered your question. Priya, go ahead.
Professor, can you give the list of mentioned downloadable model, because I have not used any like that. Means I can search for it, but then which one do you recommend, if there is any that you recommend?
Completely use case dependent. I use Gwen 3.59 billion model for writing Python codes.
Pardon?
Okay.
Which one do you use?
I use Gwen 3.59 billion. This is exactly what you see in the screen. Oh, I have stopped sharing the screen. I'm sorry. Yeah.
Gwen. Okay.
Okay. So I have a local LLM in me. So LLM view. So my LM Studio, what I do is, because it's a lot more tokens that I have to use it in Claude. I have downloaded my model. So in this case, I have a Claude. I mean, I recently changed it to Code Llama. The Code Llama is from Meta. This is again a 7 billion model, fine-tuned to write Python codes. Okay, so I have this model, and I chat to this model, and I ask this model to write codes for me. Okay, so for example, I've been writing R codes and Python codes. This is a local model that I've been using, and there are so much models available. So if you just go to Hugging Face and then go to models, depending upon your use case, there are so much models available. For example, if you want a model which can do image to text generation, so you upload an image that should give a description of the text, right? These are called clip models. So if you want to use those models, there are so many models available out there, and you can just go with the the most trending models that would give you the best models, and then just use that, and that would be my suggestion to it.
Okay, this helps. Thanks, Prof.
Yeah.
Professor, I have a question.
Yep.
Yeah. So let's consider in a predictive analysis, we have the different metrics in order to understand what is the accuracy I have, 90-80%. Like is regression classification model. But when we are talking about the LLMs, in order to get the accuracy is very tough. Client always ask to us how to make sure what is the accuracy. If I'm asking any question using LLMs, I need to make sure the answer is correct.
Yep. Yep. Let me stretch your question a little bit. Okay. Let's say I have a set of documents, and I want my LLM to look at the documents and then answer me what is there in the document. Okay. This is building this is called a RAG application, retrieval augmented generated application. Now you can build it. You can build it. It LLM will give you the answer. But how do I know the answer is correct or not? That's a question you have. The only way to test this is you give the same question to a human, to a subject matter expert, or to a human. Ask a human to respond back to that question. So you have like a 3 or 4 or rather 10 sample questions. For those 10 sample questions, you ask a human to answer the question. And you go back to LLM, ask the same question in the LLM and see the answer. Now you have a human written answer and the AI written answer. Now you compare these two answers and then you find out a score, and that's how you would do it. Again, you would go back to your traditional machine learning, accuracy, precision. You would still do recall. You would still do specificity, things like that. And then you come up with which one is the best, whether the LLM answered it correctly or not. We would do this in our DBA courses actually.
That's fine for the testing purpose. Let's consider I can ask the 10-20 question. I have an example. Let's consider I create one chatbot. This is a enterprise level chatbot, and I have the 100,000 documents which I'm getting the answer. And I ask the question, what is my last balance sheet year 2022? And I got a big answer. So how I can make sure the answer which I'm getting from my documents, liabilities, assets, I can send this information to my manager without reviewing it? And what is the accuracy? That's a big challenge nowadays in the market. So how to make sure the answer which I'm getting as enterprise level, not only me, millions of the user are getting the answer.
Unless you test this LLM, whichever LLM you are using it, with a human written answer and AI written answer on at least some sample questions. How many questions? I don't know the answer to it. Nobody knows the answer to it. You have to test this use case on 10 to 15 questions and you be happy with that. And once you're happy that it is generating the right answer, then you blindly trust it. That's what it is.
But this is the workaround. But in the reality, is a completely different. 10, 20, 100 question I can see, or I can ask the answer, or I can make sure it's working fine. But when the client are using my model, they are using asking different type of question, and we have the multiple users. They are asking the different type of questions, but they always expecting to us when I'm asking any question, to you need to make sure as a vendor what is the accuracy I'm getting, and answer should be correct, and that's our job.
Let me ask, have you built any traditional machine learning applications?
Yes.
Okay. When you built an application, you would build with some 90% accuracy or 92% accuracy. It's never 100%, right?
Right.
Now, when a new data comes in, there is a possibility the model might drift. You would do drift correction. You would periodically update the model. Exactly like that. So those are called ML ops, right? ML operation. Similarly, you need to have a LLM ops. So you need to periodically test the correctness of a LLM. If you are giving it to the vendor, once in a while, you would do whether the response you like it or not. So you have a human feedback built in when you have an application there. Even like a bigger, companies like GPT and Plot have that. So you would periodically ask the vendor whether you are happy with the answers or not. You would get that feedback ongoing. The moment your rating drops, you would go back to your LLM and see where the mistakes have happened, and you would redefine the pipeline.
That's fine. We have to redefine the pipeline, but general, and when we have the enterprise, any chatbot, where the million people are using my chatbot. So this is the big concern in the market. Client is always asking, since we are spending millions of rupees, that's your responsibility. Whatever we are asking, the question should be correct. On how to get to know the correct accuracy, it's a 90-80%. My job is not going to check the output of the LLMs. I'm here, I will ask the question, will get the answer from my documents, and I need to send to my manager without single thought. And that's your job, need to fix it. And but as a technical person, we have the challenges how to make sure that whatever the answer we are getting from the LLMs, it's a right or wrong. There is one more approach. We can pass our output to the second LLM in order to see the accuracy, but this again impact a lot of cost.
See, that is, you are exploding the cost, right? See, the problem with this, the only answer to this is test it on a sample questions, make sure it is working fine, and then give it to them, and then periodically get the feedback. Once there is a feedback drops, you would do redefine the pipelines. That's the only answer to it, and that's the way it works.
Okay.
Any more questions? I know I've been taking already 20 minutes past, but happy to take questions. Yeah. Yeah.
Just you raised about RAG just now, retrieval augmented generation.
Yeah.
Recently I read about potential attack where your competitors can poison your data by injecting false information. So when you use RAG, how can you prevent that?
I mean, you guys are asking so bigger questions. Yes, you have to build guardrails around it. There are multiple ways you can build guardrails. Either you build a guardrail that the prompt doesn't even go to an LLM, right? So you would block the prompt even before it hits the LLM, or while the LLM is processing the information, there is something called system prompts. Okay, and you would put your guardrails in the system prompts. You would say something like, if the question comes like this, you don't respond. So that's called system prompts. Or even after the LLM gives an output, you would still choose not to show that output to your end user. So you have to build guardrails, and that itself is a huge topic. And the short answer to that is you have to build guardrails.
Okay, thank you.
But when is your? I mean, I come to you, Gautam. But when is your regular classes starts? When is your machine learning classes start? When is your Gen AI class starts? Any idea?
July?
I think starting July. That's course 2. Machine learning and AI.
Course 7 is the first class, is that right?
Yeah.
I'm taking that class, so I'm doing ML classes for you guys. 10 classes, I think I'd be doing. 4 of those classes would be from one of my colleagues. She will be handling the Azure lab sessions. But I will be talking about machine learning, the traditional machine learning part. So we will talk more about this, and I will not talk about Gen AI. I will talk only about the machine learning part, and that's a lot more content covered. And usually, I'm sorry about that. Usually my classes, I will not finish it on time. I apologize. I will try to finish it on time, but do come prepared with 15 minutes of buffer time for that. And yeah, so we will do that from 4th of July. 4th of July.
Are you taking the morning class or the evening class?
I'm taking the good question. Good question. It's evening class, 6:30 to 9:30. I'm sorry, I stopped it. Please go ahead with the question.
No, so I was not a question. So while we were talking about poisoning the data and all, so I tried out one funny thing on the LLM. So I asked a question that I have a dog and it used to speak to me in English very well, but now since last 2 days it has stopped and it just barks.
Yeah.
So it it started coming back saying, you need to go to a psychologist. This is not right and all. I kept convincing it. I said that I took my dog along to the psychiatrist. Now the psychiatrist also convinced that this is a problem and all those. So after like 20-25 minutes, I could convince that it is. Then it said that at this point of time, I do not have an data where a dog speaks and it actually barks. So yeah, sometimes you try to poison it, but sometimes it doesn't happen.
That's a problem with LLM. LLM hallucinates all the time. It will never say the correct answer. Okay.
Yeah.
Yeah. So that's where the RAG applications all that comes in. By the way, I'm done with the class. Those who don't have any questions to ask and you have some other work, I do respect your time. Feel free to drop off. I'm done with the class. But if you have questions and if you want to have a little bit more chat, I'm happy to stay here and then answer your questions. For those who want to drop off, feel free to drop off. I will upload the PPT in the portal.
Thank you. Great class. Bye bye.
Thank you.
Thank you,
Awesome class.
Professor.
Thank you, Professor. Have a good
Thanks,
night.
Professor.
Thank you, doctor. Thank you.
Thank you, Professor.
Thank you.
Thank you.